calculated values. For the border box property, we can call them set values. Now when looking at the CSS properties, we have a width of 500 pixels, a height of 200 pixels. We can see straight away what the total width and height of our element will be. We don't need to do any calculations of the element in the browser. Let's play around with this in VS Code. In our index.html file, I'm just going to add another empty div, and I'm going to give it the class box2. In app.css, I'm just going to copy this rule. I'm going to paste it over here, and I'm going to update the selector to box2. I'm going to leave all the values, but just add in the box sizing property. And I'm going to set the value to border box. Now again, the default value is content box. So you could explicitly define it here, like that, but there really is no need. So I'm just going to remove it. All right, let's check this out in the browser. So as you may expect, our second box is now smaller than our first box. And that's because the width is actually the width we're defining over here. The total width of this box is 800 pixels. Whereas for box 1 above, the total width is the width of 800 pixels plus the padding either side plus the border either side. Let's check this out in DevTools. I'm going to select the second box, and you can see the little pop-up above the box in the browser is showing the total dimensions of 800 by 400 pixels. If I compare that to box 1, the total dimensions there are 920 by 520 pixels. Jumping back to box 2, let's go look at the box model. You can see the border is exactly the same as what we set. The padding is the same as what we set, but the width and height have both been reduced. So in a nutshell, by default, the total width and height will be the sum of the width and height values plus the padding plus the border. But when we set box sizing border box, the total width and height of the elements are immediately set with width and height. The padding will be the same, the border will be the same, and to make this mathematically work, the actual content will reduce. So let's now discuss box sizing guidance. In almost every single project, you'll want to set the border box property on the universal selector. As a reminder, the universal selector sets the border box on all boxes. So in other words, every single element will have border box applied to it. And in fact, this is usually one of the first things to do in a new CSS document. Now, the reason we want to do this is because it's much easier setting values in CSS and knowing that those will be the total values in the browser. If we didn't change the box sizing to border box, setting values in the CSS, it would actually be a lot more complicated to know how the final dimensions of your elements will look in the browser. So let's wrap up this chapter. Now I'm going to do something I really don't like doing, and that is starting the next summary card without finishing the one we've been working on, the CSS box model. So I'll now be starting the summary card, setting global rules with the CSS box model. Now the reason I'm doing this is because I don't want the material we discussed in this chapter on the CSS box model summary card. We're going to finish that off in the next chapter when we learn about margin. I've had to order the topic this way, that we discussed box sizing now, as it has to do with the content, padding, and border, which we've already covered. So in this chapter, we looked at box sizing. We first looked at the value content box, which in CSS look like this, box sizing content box, and this is where the set width is the width of the content only, and content box is the default value. So let's say we applied a width of 500 pixels to our element. This would be the width of the content shown in purple. We could then apply padding and border, which would be added on top of this width of 500 pixels. So the total width and height of our element would now be more than 500 pixels, as it includes padding and border. The other value we looked at was border box. In CSS, it looks like this, box sizing border box. This is where the set width will be the sum of content, padding, and border. So having box sizing border box and a width of 500 pixels will look like this. Our content will shrink so that the content, padding, and border have a width of 500 pixels. And we can see the difference very clearly between the two by adding in these orange lines, where for content box, we can see the width of 500 pixels is just the content, where for border box, it's the content, padding, and any border. So let's now apply the box sizing property on the Quill homepage. Essentially, every single element is going to have the border box property. All right, let's jump into VS Code and add in the box sizing property. So inside our app.css file, I'm going to come right to the top, and we actually already have a comment about adding in the universal selector here. So I'm going to remove this, I'm going to add the universal selector, grab our curly brackets, I'll grab the box sizing property, and add the value border box. Let's check this out in the browser. Now immediately, the difference won't really seem that significant. But let me just show you a place where something significant has changed. This call to action section will now have the width we actually set. If you remember earlier on, we're setting the CTA card with a width of 1000 pixels. So now the total width of this card will be 1000 pixels. Let's check this out in DevTools. I'm going to select this element, and you can see on the pop-up there, the width is 1000 pixels. Looking at the box model, you can see the padding is the padding we set in the CSS, 200 horizontally and 100 vertically. And you can see that the width is being reduced. It's 600 pixels. Now, just a small comment. You can see that the Get Started button is kind of cutting into the padding a bit. The source of this issue is the same we've seen earlier, where our buttons at the top are overlapping. We will be sorting this out soon. Now let's jump back to our universal selector, and I'm just going to comment it out to show you the impact it's had on the CTA section. I'll refresh, and now you can see the width of the CTA card is now a lot bigger. It's 1400 pixels wide. This is the default box sizing value of Content Box, where the width 1000 pixels is being summed up with two lots of 200 pixels for left and right, giving us a total width of 1400 pixels. So I hope you can see why we want to be using box sizing border box. It means that whatever values we're setting in our CSS will be the total values in the browser, making the size of elements much more predictable. Moving forward through this topic, we'll now learn how to create space between elements by adjusting the margin. We'll look at what is margin, the longhand and shorthand margin properties, and margin design guidance. So what is margin? Margin is the space outside of an element's border, creating distance between it and neighboring elements. Let's take a look at the artwork analogy we've been using throughout this topic. To recap what we've learned so far, we'll start with the Banksy artwork on the left. The painting itself is the content. The area surrounding the content is the padding, and the frame of the painting is the border. For the LeBron James poster, all we have is the poster, so the content. There's no padding and no border. And for the framed poster on the right, the poster itself is the content, and there's no padding. The frame is directly touching the poster, so we just have border. Now margin is the distance between each of these artworks. It's equivalent to how you would space the paintings on your wall in your home. So let's look at an example of margin being used on a web page. I'll first highlight the different containers of elements. We have a navigation menu, some big heading text, a paragraph, a button, and a small piece of text over here. Now margin is used to separate each of these elements. We have some margin between the navigation menu and the big heading text. We have margin between the heading text and the paragraph, and we have margin between the paragraph and button. There would also be some margin from the bottom of the small text all the way to the next element below the content we see on this page. So as you can see, margin helps create distance between elements. So let's check this out in DevTools. First up, I'm just going to zoom out a bit. I'm then going to open up DevTools. And let's start by looking at the big heading. In the CSS section, if I scroll down to the box model, you can see over here, this has a margin of 50 pixels at the top and 24 pixels at the bottom. Let's have a look at one more element to see how margin's being applied. If I hover over this paragraph, you can see an orange box below. So we have some margin below this paragraph, separating it from the button below. So let's now look at how we define margin in CSS. We'll be starting off with longhand margin. Just like with padding, where we had longhand and shorthand, longhand margin sets the margin on individual sides. If you remember from the padding chapter, it's the same thing, where we have a longhand version and a shorthand version, which we'll see soon. So let's take a look at this card to understand longhand margin. The area in purple is the content, the red line is the border, and the green area is the padding. So let's go add some margin to separate this from other elements. We'll start with the top by adding a margin of 5 pixels. In CSS, that would look like this, margin-top 5 pixels. On the right, we'll add some margin of 20 pixels. this would be margin right, 20 pixels. We'll add 5 pixels on the bottom. So this would be margin bottom, 5 pixels. And we'll add 20 pixels of margin on the left. And this would be margin left, 20 pixels. Adding each of these margin values creates a kind of force field around the element. So other elements would be positioned around this force field. So let's play around with margin in VS Code. I've got a blank index.html file, and I've linked up a CSS file, app.css, which is currently blank. In the HTML file, I'm going to add 2 divs, and I'm going to give it a class of box1, and the second one a class of box2. Inside the app.css file, I'm going to select box1. I'll give it a width of 500 pixels, a height of 500 pixels, and a background color of salmon. I'll copy this and paste it here, update this to box2. I'll leave the width and height properties, and let's give this a color of khaki. Alright, so let's check this out in the browser. Alright, so you can see, as expected, we just have 2 stacked boxes. Let's now go add margin to box 1. We'll start with margin top and give it a value of 40 pixels. I'll refresh the browser. You can see the box has visually moved down, as we've added 40 pixels to the top. Let's go add values to all the sides. We'll add margin right of 20 pixels, margin bottom of 50 pixels, and margin left of 30 pixels. Let's refresh. So you can see now this force field appearing around the box. Let's open up DevTools to see how this looks in the box model. I'll click on the element, and you can see in orange the margin all around the element. Now, just a quick note. For margin right, it isn't so obvious that there is a margin here because there's no element currently next to it. And actually, being able to place block elements next to each other is something we still need to learn about. So I just wanted to highlight that although it doesn't look like there is any margin because there's no element next to it, there is margin being applied, which we can see in the box model in DevTools. So now that we've looked at longhand margin, let's take a look at shorthand margin. This sets the margin on all sides at once. There are 4 different cases. The first one is setting all sides in one go, and that looks like this, margin of 20 pixels. The 20 pixels is applied to all 4 sides at once. Using this is quite common. Next up, we have applying margin vertically and horizontally, and that looks like this, where the first value, 10 pixels, is applied vertically, that is margin top, margin bottom, and the 20 pixels is applied horizontally, that is margin left, margin right. Using this is also common. The next case is applying margin top, horizontal, and bottom, and it looks like this. The first value of 10 pixels is applied to the top, the second value of 20 pixels is applied horizontally, so margin left and margin right, and the third value, 5 pixels, is applied to the bottom. Using this is fairly uncommon, so don't worry too much about it. The fourth case is applying margin to each side in one go, and it looks like this. The first value is the top, the second value is the right, the third value is the bottom, and the fourth value is the left. So we're starting at the top and working our way around clockwise. Using this is kind of common, as there may be some use cases where you do want different margin values on each side. So let's jump back into VS Code and play around with this. I'm going to get rid of these longhand margin properties we played with earlier. So let's do the first case, where we use the margin property and define a single value which will apply to all sides. Let's do 50 pixels. So as you can see, 50 pixels has been applied to all sides of our element. The second case was where we had vertical and horizontal. So let's do 30 pixels for the top and bottom and 60 pixels for left and right. And you can see how 30 pixels has been applied top and bottom and 60 pixels left and right. The third case, which wasn't that common, was applying first margin to the top, which I'll do 20 pixels, then horizontally, so left and right, let's do 40 pixels, and then the third value was the bottom, let's do 60 pixels. Checking it out in DevTools, we can see how these values have been applied, 20 to the top, 40 left and right, and 60 to the bottom. The last case was applying a value for each side. We start at the top with 10 pixels, let's move to the right, 20 pixels, at the bottom, 30 pixels, and on the left, 40 pixels. Checking this out in DevTools, you can see 10, 20, 30, 40 have each been applied, starting at the top and working clockwise. So let's now look at some margin guidance. We use margin to apply white space between groups of elements. On this web page here, we have our main heading and paragraph text, where we have a small margin in order to keep the text close together. Whereas for the button and image over here, the different elements are further apart. So we use a larger margin value to apply white space between these elements. So in other words, some elements we want to keep close together, like a heading and paragraph, so we use a small margin value, whereas other elements we want further apart, so we'd use a larger margin value. We also use margin to apply white space between sections. On the same web page, we have a section over here, and we have another section down here. You can see that in this case, there's a lot of white space between sections. So it's very common to use much larger margin values between sections in order to keep them distinct. Now, it is common to control spacing between elements with margin and other more modern techniques. On this web page, we have our navigation and our main heading, and the spacing between these elements is handled by margin. Now, these cards down here also have spacing between them, but this is handled by other techniques we're going to learn about later. Okay, so let's jump back to our summary card, the CSS box model, and finish it off by adding in margin. We first looked at the longhand margin property, where we set the margin on each side of our element through margin top, margin right, margin bottom, and margin left. I also mentioned I like using margin bottom to create white space between different elements. We also looked at the shorthand margin property, where similar to padding, there are 4 possible options. The first is setting a single value, which adds the same value of margin on all 4 sides of our element. The second option is using 2 values, where the first value, 10 pixels, is margin top and bottom, and the second value, 20 pixels, is margin left and right. The third option is using 3 values, where the first value, 10 pixels, is margin top, the second value, 20 pixels, is margin left and right, and the third value, 5 pixels, is margin bottom. And the final option is using 4 values, which sets the margin on each side, starting at the top, moving right, bottom, and left. And we discussed the most common use of the shorthand margin property is the first 2. So let's go and apply margin to the Quill project. On the home page, we have the navigation menu over here and the main heading over here. Between these elements, we'll be applying margin. We have the paragraph element here, where between the heading and the paragraph, we'll also be applying some small margin. And between the paragraph element and the buttons, we'll also be applying some small margin. We'll then be using a large margin value between the bottom of the buttons to the next section of the page. Now in the navigation bar, the spacing between the logo and the buttons, and between the buttons themselves, will be handled by other techniques we'll be learning about later. For the features section of the page, we have the main heading, and as I mentioned before, we'll have some margin separating the bottom of the buttons above to this main heading. For the feature containers, we have 3 sets of these, 1 here and 2 below. We'll be applying some small margin between the heading and the top of the first feature container. And for spacing between all the elements inside the feature container, we'll be using other techniques we'll learn about later. For the bottom of the page, we have the Get Started call to action card. There'll be some margin between this and the bottom of the last feature container on the previous page. We'll have some small margin between the Get Started Now text and Get Started button. And we'll also have some margin between the bottom of the call to action card and the footer. For spacing inside the footer, we'll be using other techniques we'll learn about later. Now, before we jump into VS Code and add margin, we need to talk about the idea of a spacing system. This is where we define specific spacing values that are used throughout the project. We start with a base value, like 10 pixels. This is called our base unit. We then use multiples of this unit to define our spacing system. So we start off with increments of 5, like this, giving us the range from 5 to 30 pixels. We can then use increments of 10 pixels, giving us values from 40 to 100 pixels. We then increase the increment to 25 pixels to give us 125 pixels and 150 pixels. We then increment the value by 50 pixels to give us 200, 250, and 300 pixels. And then finally, we increment by 100 pixels to give us 400 pixels and 500 pixels. So this now gives us a predefined spacing system that simplifies the design process and ensures consistency. So when we're thinking of margin values, when we're coding this up, we have a system we can refer to instead of trying to continually make them up. And it also ensures consistency, where similar values will be used throughout the project. Now, I've just defined this specific spacing system. This makes sense for me, but of course you have complete freedom to choose whatever values you like. As a general rule of thumb, you will have more of the smaller values, as this provides more control for smaller spaced elements, where generally larger margin values, you don't need such fine tuning. So let's go and code this up. So I'm back inside our Quill project, inside the app.css file. The first thing I want to do is add the spacing system in our design guidelines in this comment. I'm going to copy border radius, paste it down here, and change the heading to spacing system. I'm going to add in the values we just looked at previously. 5 pixels, 10 pixels, 15 pixels, and to avoid boring you, I'm just going to add them all now. Okay, so I've added in all the different pixel values for our spacing system, so we have an easy place to reference them up the top here. So let's start with the margin between the navigation and the main heading. Now, to make this easier to see when we make changes, I'm just going to open up the index page on the Quill homepage. So first, let's add the margin between the navigation and this heading. So I'm going to scroll down to that section, and I'm going to add a margin bottom to this navigation. Now, you could also add a margin top to this heading, but I prefer using margin bottom values when adding margins, and I'll be using that for every single element. Whichever approach you use, whether it's margin top or margin bottom, just be consistent. It makes your code a lot cleaner. Now, I don't yet have a section for the navigation menu, so I'm just going to copy this and call it navbar. In our HTML, the navigation menu is inside the semantic nav element. I'm just going to add a class to this and call it navbar. So the navbar class will select the entire navigation menu, including the logo and buttons. So let's go select that, navbar, and let's add a margin bottom of 200 pixels. Let's refresh, and you'll see now we get some nice spacing between the navigation bar and this major heading. And again, I'm using a value of 200 pixels, which is inside our spacing system. Let's now add some small margin between the heading and paragraph. You will notice that there actually is margin there already. If I open up DevTools and inspect the heading element, you can see in orange some margin top and bottom. This has been applied by default and is something we're going to correct soon. But you can see for now, this heading text and paragraph text look a bit disconnected. So we want to apply a small margin value to group them better visually. Now to achieve this, I'm going to add a margin bottom to our heading over here. It'll be a small value that will bring this closer together. If we head to our index.html file, our heading currently doesn't have any class, so we won't be able to select it. So let's go add a class of hero heading. I'll copy this text, I'll select the class, and add a margin bottom of 10 pixels. So let's refresh, and you'll see that the paragraph now moves closer to the heading. Next up, let's create some space between the buttons and this paragraph. So to do that, I'm going to add some margin bottom to the paragraph. I first need to add a class to the paragraph in the HTML so that I can select it. Let's call it hero paragraph. I'll copy that, select the class, and let's add a margin bottom of 100 pixels. Let's refresh, and you'll see now some white space between the paragraph and the buttons. So this is looking good. We've added a small margin value between our main heading and paragraph, grouping that content together. We've created some distance between our navigation and heading text over here. We've also created a bit of distance between the paragraph and the buttons. The last thing we need to do is add some margin between our entire hero section and the start of the features section here. Back in the HTML, we have our hero section inside the semantic section element with the class hero section, with the next section being the features section over here, all inside the main semantic element. So what we're going to do is add margin bottom to the hero section. We have that class already selected over here. So let's just go add margin bottom. And because we're creating some white space between different sections, so I'm going to use quite a large value of 300 pixels. So you can see by doing that, we get large white space between the different sections, the hero section over here and the start of the features section over here. Now looking at this, I've noticed that I think these buttons are too far away from this paragraph text. So what I'm going to do is update the margin bottom on the paragraph text to something like 50 pixels. So let's refresh and see how it looks. Okay, that looks a lot better. The text is still grouped nicely, and we have a bit more distance between our buttons over here. Now, that iterative process I just went through is very common when applying margin. You'll just experiment with different values until it just looks right to you. So let's scroll down to our features section. All of the spacing for each of these containers, so this feature container here, this feature container here, and this feature container here, is going to be handled by other techniques we're going to look at later. So I'm not going to worry about spacing of any of these elements just yet. Let's just add some small margin to this heading over here so that we can create some space between it and the start of this container. Inside our HTML, we've already defined a class for this, features main heading, which we can see over here. So let's just go add some margin bottom, and let's give it a value of 80 pixels. Nice, so that creates just a bit more space between the primary heading and the first feature container. The last thing we need to do for the features section is add some margin between the entire features container and the call to action section. Jumping back to our index.html, we essentially need some margin between this section, the features section, and our call to action section. So we're going to be applying some margin bottom on the section element. Currently, we don't have a class for that, so let's go add one, and we'll call it class features section. I'll copy that text, head to app.css, and because I'm selecting the whole container, I usually put that right at the top. So I'm going to add it there, and we'll add a margin bottom, again of 300 pixels, just like we did between the hero section and the features section up here. So let's refresh, and you'll see we now have a good chunk of white space between the features section and the call to action section. Now the last thing we need to do is add some margin between the call to action section and the footer at the bottom. In our index.html, we have the call to action section, all contained within the HTML section semantic element, and we have the footer down here, all contained within the footer semantic HTML element. So all we're going to do is add some margin bottom to the entire call to action section. We already have a class for that, CTA section, which was actually commented out earlier on in the course. So I'm going to add that back in, and we're going to add margin bottom, and because we're trying to create a lot of white space, again, I'm going to use a large value of 300 pixels. And you can see that creates a nice amount of distance between the call to action section and the footer. So let's take a look at what we've done here. You can see adding margin to CSS makes a significant difference to how the web page looks. The use of white space helps group related elements together, as well as separate other elements. We have nice space between our navigation bar and our heading. We've grouped these nicely together. We've created a bit more space between the buttons and the paragraph. We've created a nice amount of white space between the hero section and features section. We've separated this heading from the first features container. We've created a nice amount of white space between the features section and call to action section. And we've also created a nice amount of space between the call to action section and the footer. Now, before we finish up, I just want to highlight something. Most of the work we did here was just adding margin vertically, where I used the margin bottom property. As I mentioned, you could have used margin top. I just prefer using margin bottom, and whatever you choose, just make sure you're consistent. Now, the process of just using margin vertically is actually fairly common. We're going to be using other techniques, which we'll be learning about in the Flexbox and CSS grid section, to help us with layout and spacing within different containers, like this feature container here. When we get up to that, there are other properties that help us with spacing. Margin is typically used to help us separate between major sections. And in fact, we're going to see later, we'll be using other techniques instead of margin to create space between different elements like our heading and our paragraph and buttons. That is, the smaller values of margin we used. Margin is typically the most useful in creating lots of white space between different sections. So between the hero section and the features section, or the features section and the call to action section, and the call to action section and the footer. That is where margin is most commonly used. Now it's time to learn how to control the layout and visibility of elements with the display property. We'll be discussing how the box model applies to block and inline elements, the display property, the inline block value, and display design guidance. So before we start looking at the display property, I want to do a quick refresh on what are block and inline elements. All HTML elements are by default either a block or inline element. Looking at block elements first, their main feature is they always start on a new line, and we can represent them like this. They also take up the full width of a page. And here are some common block elements. For inline elements, these do not start on a new line, unless they come after a block element. And that's because the block element extends the full width of the page, so pushes the inline element onto a new line. And we can represent inline elements like this, where they're able to butt up against each other. Unlike block elements, they only occupy the width of their content. And common inline elements include these ones here. So now that we've recapped block and inline elements, let's talk about block elements and the box model. Block elements follow the box model rules, so applying any properties work as expected. So I'm going to represent a block element with this purple box here. It could be any block element, like a heading, paragraph, or div. We can apply width to the block element. We can apply height to the block element. We can apply padding to the block element. We can apply a border to the block element. And finally, we can apply margin to the block element. All these properties work as expected. Let's play around with this in VS Code. So I'm in a new index.html file. I've grabbed the boilerplate, and I've also linked up an app.css file, which is currently empty. I'm just going to go add a div, which we know is a block level element. In app.css, I'll select this div, and I'm just going to go add all the different box model properties. Let's give it a width of 500 pixels, a height of 500 pixels. We'll give it a background color so we can see it. Let's do light coral. We'll give it some padding of 50 pixels, a border, which will make 10 pixels solid black, and finally some margin all around it of 100 pixels. So let's check this out in the browser. So as expected, nothing crazy going on here. For block level elements, all the box model properties apply. Let's confirm this inside DevTools. I'll inspect the element. We'll go down to the box model. We'll see the width and height has been applied, padding's been applied, the border's been applied, and the margin's also been applied. So for block level elements, everything works as expected when applying box model properties. So now let's look at where things get a bit interesting. And that's inline elements and the box model. Inline elements do not follow the box model rules, so applying some properties do not work as expected. In purple here, I'm representing an inline element. This could be something like an anchor tag or a container element like a span. So for width and height, this cannot be set. The width and height of the inline element will just be the width and height of the content. We can't manually override the width and height with the width and height properties. For block elements, we can. If this was, for example, a heading and it had a width and height set by its own content, we could still then apply the width and height properties to override those values. But we can't do this for inline elements. Let's now take a look at padding. For padding, it applies but only pushes content away horizontally. We'll see exactly what this looks like inside VS Code soon. Let's now take a look at border. For border, just like padding, it applies but only pushes content away horizontally. And we'll see exactly what this looks like inside VS Code soon. Let's now take a look at margin. For margin, it only applies horizontally. So no margin is applied vertically. To get a better understanding of what this all means, let's jump into VS Code and play around. I'm back in the file we were working in before. I'm just going to get rid of this div and get rid of the styles here. I'm now going to add a chunk of paragraph text. I'll grab the p tag and I'll type lorem times 40 to get a whole bunch of paragraph text. I'm going to go towards the middle of this chunk of text, and I'm going to add some span tags, which we know are inline elements. I'll wrap this word in the span. And let's just give it a class of inline element to make it clear for us. I'm now going to head over to app.css. I'll select this element. It had the class inline element. And let's just start by giving it a background color. I'll choose light green. So let's check this in the browser, and we'll continue to add box model properties and see their impact. All right, so here's that span element we've given a green background color. So let's go add a height and width. I'll give it a height of 400 pixels and a width of 400 pixels. I'll refresh and you'll see absolutely nothing has happened. And that's because for inline elements, width and height don't work. Let's now give it some padding. I'm going to apply 100 pixels top and bottom and 100 pixels left and right. I'll refresh. And as you can see, the padding has been applied. The green extends 100 pixels top and bottom and left and right. However, it's only pushed content horizontally. You can see this word here and this word here have been pushed away from our span, but the text below and above has not moved. Let me just comment out the background color. So you can better see now that the text above and below is still present. It's only left and right that the text being pushed away. And if I turn background color back on, you can see that the padding has still applied, but it's having a weird effect, only pushing content away horizontally. I'll now add a border. Let's do 20 pixels, solid, and red. I'll refresh, and again, the same thing is happening. The content horizontally, that is this word here and over here, have been pushed further horizontally, but there's been no impact on the content below or above. It's staying in place. The last property is margin. Let's apply 100 pixels top and bottom and 100 pixels left and right. I'll refresh, and look what's happened here. The margin has simply not applied top and bottom, but it has applied left and right of the content. You can see over here, there's 100 pixels between the edge of the border and the word over here. And there's also 100 pixels between the edge of the border and this full stop or period over here. So long story short, there's just some weird stuff going on with applying box model properties to inline elements. And we're going to see soon how we can correct this, as being able to apply box model properties to inline elements is important. So let's now take a look at the display property. This sets how the element is formatted and positioned. It looks like this, where display is the property, and in this case block is the value. The values can be block, inline, inline block, flex, and grid. The value block is the default value for block elements, and inline is the default value for inline elements. So for example, a heading, which is a block element, by default has a display property of block, whereas an inline element, like an anchor tag, has by default display inline. Now, not that you would do this, but you could change the inherent behavior of these elements. So for example, a heading, which is a block element, I could add the CSS property display inline, and this changes the heading to an inline element now. The other value inline block we'll be talking about now, and the other values flex and grid form their own topics later on in the CSS section, as there's a lot to talk about with those display values. So let's now have a look at the value inline block. This combines features of block and inline elements, and it helps correct some of the issues we saw earlier, where box model properties were applying very weirdly to inline elements. To understand inline block, let's quickly recap how CSS box model properties apply to block and inline elements. For block elements, the CSS property is display block, which again is just default for block elements. Block elements start on a new line, and they take up the full width of the page. For the box model properties, width and height can be set. Padding applies as expected. Border applies as expected. And margin applies as expected. For inline elements, the display value is inline, and again is set by default on inline elements. Inline elements do not start on a new line, and they only occupy the width of their content. For the box model properties, width and height cannot be set. Padding only pushes content away horizontally. Border only pushes content away horizontally. And margin only applies horizontally. So let's now talk about inline block. The display value for this is inline block. Inline block takes the inherent display properties of inline. That is, it does not start on a new line, just like inline properties, and it only occupies the width of their content, just like inline properties. So an inline block element is exactly like an inline element. However, when applying CSS box model properties, inline block takes all the good stuff from block, in that width and height can be set, padding applies as expected, border applies as expected, and margin applies as expected. So the display value inline block helps solve the problems we saw when applying CSS box model properties to an inline element. Inline block gives us an inherent inline property, which we still need, but allows us to apply box model properties as expected. Let's take a look at this inside VS Code. So just as a reminder, this element over here is a span, which is an inline element. And by default, its display value is set as inline. Let's go explicitly set it though. Display inline. If I refresh the page, nothing will happen, because by default, this is an inline element. Let's now change it to block. I'll refresh, and you can see that this inline element, the span, has now been overridden and becomes a block element, where all these properties are applying as expected. That is, it has height and width set, padding set, border set, and margin set. So it's behaving exactly like a block level element. Also note that just like a block level element, the element starts on a new line. And because of this, we don't see any other text from the paragraph before it or after it. It's on its own line. Let's now change this to inline block. I'll refresh and watch what happens. So all the box model properties still apply as if it were a block element. That is, it has height and width, it has padding, it has border, and it has a margin. But the big difference now is that it's still inherently behaving like an inline element. That is, it is not starting on a new line. You can see we have text to the left and right of it, because with inline elements, they don't start on a new line. You can have other content surrounding it. So inline block fixes the issues we saw earlier. We're able to apply CSS box model properties, but the element still inherently behaves like an inline element, where other content can appear to the left and right of it, because it doesn't start on a new line. So let's now talk about how we use inline block elements by looking at some guidance. It is common to apply inline block to inline elements so they can flow inline, but all box properties can be applied. When I say flow inline, all I mean is that they can go next to each other. And for box properties, we're specifically talking about padding, border, and margin. Looking at this web page as an example, these buttons over here are anchor tags, which are inline because they're appearing next to each other, but also have box model properties applied, like padding and margin. Another example is this text over here in the heading. We'd use inline block on a span when applying padding and when margin is needed. So the word focus over here would be wrapped inside a span element so that we could apply things like padding, background color, border, etc. So it's important that the span element remains inline so that it appears next to the word revenue, but we still need to apply those box model properties. So as a general rule of thumb, we're usually applying inline block to most inline elements on our web page. Now, before we finish up, I want to talk about something called replaced inline elements. These are inline elements where the content is sourced externally and is not part of the HTML markup. To understand this, let's first talk about regular inline elements. As we know, they do not start on a new line. They only occupy the width of their content. Width and height cannot be set. And padding, borders, and margin do not apply as expected. Examples of regular inline elements include anchor tags, span, subscript, and superscript. Now let's talk about replaced inline elements. Just like regular inline elements, they do not start on a new line, and they also only occupy the width of their content. But with box model properties on replaced inline elements, they apply as expected. Width and height can be set, and padding, borders, and margin apply as expected. Replaced inline elements include the image tag, input, select, and text area. So replaced inline elements, as the name suggests, is when the browser is actually replacing the HTML element with something else. So for example, in the HTML markup, we put an image tag, but on the web page, we actually have a real image. It's being replaced. Same with the input tag. In the HTML markup, we have input, but then on the real web page, an actual input field renders. The input tag is being replaced by an input field, where I'm able to type something into the box. So replaced inline elements, in a nutshell, there's a subset of inline elements called replaced inline elements, and the most common ones we use are image and input, whereby the box model properties do apply just like a block element. So let's check this out in VS Code. I'm back in our app.css file, and I'm going to remove this display property. This will default back to a regular inline element. And as you know, we're going to have a whole bunch of issues when trying to apply the box model properties. In the index.html file, I'm going to add an input, which, as I said before, is a replaced inline element. You can see it down the bottom here. Now it's replaced because an actual input box is rendering on the page. The tag input is being replaced by something else. In this case, an input field. Let's give it the class replaced inline element. I'm going to head over to app.css and select it. Let's now go apply some box model properties. Let's give it a width of 400 pixels, a height of 50 pixels, padding 100 pixels top and bottom, and 100 pixels left and right. A border of 10 pixels solid green, and margin of 50 pixels top and bottom, and 50 pixels left and right. I'll refresh, and you can see all the box model properties have applied to this replaced inline element. Let's double check that in DevTools. So you can see over here, the width and height's been applied, padding's been applied, border's been applied, and margin's been applied. So long story short, just be aware that there's this thing called replaced inline elements where the box model properties do apply. And the most common replaced inline elements we're going to be working with are images and inputs. So for those, you don't actually need to apply inline block. Whereas for things like anchor tags and spans, we should be applying inline block so that they can behave like an inline element, but we're also able to apply the box model properties as we'd expect them to work. So let's finish off this chapter by adding to our summary card, setting global rules with the CSS box model. In this chapter, we looked at the display property. To summarize what we've learned, I've made this table where I have the different values as columns, block, inline, and inline block. And in the rows, in purple, I have behavior, and in orange, I have box model properties. So let's start with block elements. For block elements, they start on a new line. They take up the full width of the page. Width and height can apply. Padding applies as we'd expect. Border applies as we expect. And margin applies as we expect. For inline elements, they don't start on a new line. They don't take up the full width of the page or container. You can't set width and height. Padding doesn't apply as we'd expect. Border doesn't apply as we'd expect. And margin doesn't apply as we'd expect. Now, none of this should be new to you, but what is new is the new display value inline block, which retains the inherent behavior of an inline element, but allows us to apply box model properties. So for inline block, it doesn't start on a new line, and it doesn't take up the full width of the page or container, just the content of the inline element. So an inline block element keeps all the inherent characteristics of an inline element. But inline block now applies box model properties how we'd expect. We can set width and height, padding applies as we'd expect, border applies as we'd expect, and margin applies as we'd expect. So let's go and add the inline block element to our Quill project. So let's identify the different inline elements we need to do this for. The first are these buttons over here, which are anchor tags. By default, they're inline elements, so we're going to change them to inline block so that box model properties apply to these as expected. The text mindful living currently sits inside a span, which is also an inline element, so we're going to change that to an inline block. So again, box model properties will apply as expected. In the top left, we have our Quill logo, which is an image. For the image, there's no need to set to inline block, as it is a replaced inline element. If you remember from earlier, replaced inline elements, like images and inputs, are inline elements where the box model properties do apply as expected. Further down our page, we again have a span over here, so we need to update that to inline block. The image over here is a replaced inline element, so we don't need to update that because the box model properties will apply as expected. And at the bottom of the page, this button over here is an anchor tag, so we need to update that to inline block. So let's jump into VS Code and make these changes. So I'm back inside our app.css file. In our global styles over here, I'm going to scroll down to the anchor tag and change this to display inline block. Because this is using the type selector on the anchor tag, all anchor tags will now become inline block. I'm then also going to go select the span element using the type selector. And I'm going to change this to display inline block. and this will ensure any span element has the display property inline block. Now, I've applied these display properties globally. I want all my anchor tags and all my spans to display inline block. This ensures any future anchor tags or spans I add will have this applied. Now, I could have applied the display property inside these components. Our button class is being applied on the anchor tag. So I could have added display inline block over here. The only problem is that that only covers buttons. There could be other kinds of anchor elements I add later that I also want to be inline block. And the same thing with this highlight component. I could have added display inline block over here, but that would only cover this particular component. Whereas what I want is to globally apply inline block to my spans and anchor elements. So it covers me for all future cases where I might add another specific span component later on. So let's check this out in the browser. Now, before I refresh to see the impact of changing to inline block, I want to highlight some of the issues we were having before. The most obvious one is because the box model properties do not apply to inline elements, that is, these anchor tags over here, they're kind of overlapping. So that's what this issue has been caused by, these being inline elements. And you can see the same thing over here. I'm going to refresh the browser now, where we'll see the impact of changing these to inline block. Beautiful. Finally, we've fixed this issue. The buttons no longer overlap. The box model properties are being applied as expected. Now, with the highlight, the change here is quite subtle, but something is happening. I'm going to comment this out to go back to this span being an inline element. Now, if you remember, for inline elements, box model properties apply quite funny, where for padding, it is applied, but only pushes content away horizontally. So the word to and a are pushed further away. But for top and bottom, any content is not pushed further away. I'm going to uncomment this and refresh. And I want you to pay close attention to the word app. So I'll save and refresh. And although subtle, the word app has now moved down slightly because the padding is now moving content away vertically. So long story short, it's just best practice to apply inline block to your regular inline elements so that box model properties can apply as expected. Now, one thing I want to clarify before we finish up, which may cause a bit of confusion, is why these buttons are appearing stacked like this. This is block level behavior, not inline element behavior. And by changing to inline block, if you remember, it preserves the inline nature of the element. So they should appear next to each other. Now, the reason is because of how it lives in our HTML. Inside our HTML, these anchor tags, the inline elements, are being wrapped by list items inside an unordered list. A list item is a block level element. So the block level element is what's causing the buttons to be on their own line. Whether the anchor tag is display inline block or its default of inline doesn't make a difference. The fact that it's in a list item is what's causing this to happen. I just wanted to highlight that changing it to inline block is not causing the behavior of its stacking. It's just how it's structured it in the HTML. And if I actually remove this from the list item, like this, from the unordered list, and place it there, and place this one below it, you'll see that they actually do go in line. So I just wanted to highlight that in case you were thinking about why that's happening. And really just emphasize that applying inline block keeps the inline nature of the element, but allows us to apply CSS box model properties as we'd expect them to apply. Let's now look at how to ensure consistent styling across different browsers by looking at CSS Reset. We'll be discussing browser default properties, CSS Global Reset, and Normalize CSS. So let's first discuss the browser default properties. Browsers have built-in CSS default rules that style HTML elements. For example, on the body tag, there's a default 8 pixels of margin. For a heading 1, it has 21 pixels of margin top and bottom, a 32 pixel font size, and 700 font weight. For a paragraph tag, it has 16 pixels margin top and bottom, 16 pixels font size, and 400 font weight. For the ordered and unordered list tags, there's 16 pixels margin top and bottom, and there's 40 pixels left padding. These are just some of the common HTML elements, but as you can see, the browser gives them default styling rules. So let's check this out in VS Code. So I've got a new index.html file, and I've already linked up an app.css style sheet, which is currently empty. Let's go add some elements. I'll add an h1 and give it the text heading 1. I'll add a paragraph and put in some placeholder lorem ipsum text. And let's add an unordered list. We'll add 3 list items and just say list item 1, list item 2, and list item 3. So let's check this out in the browser. So I'm straight away going to open up DevTools, and let's select the different elements. Let's start with the heading. You can see straight away in orange above and below the margin. On the box model, you can see that 21 pixels has been applied top and bottom, which is the default styling. You can also see the H1 has a default font size of 2 Ms. We haven't actually covered M units yet, and we'll be doing that in the next topic. But for now, you just need to know an M is 16 pixels, so 2 times 16 is 32 pixels, which is the default font size for heading 1. And you can see the font weight over here is bold, which is a value of 700. Let's move on to the paragraph. So I'm going to go select it. And again, you can see there's orange above and below. And if we look at the box model, you can see 16 pixels has been applied top and bottom. And let's finally check out the unordered list. You can see there's orange top and bottom, which is the margin. And you can see green on the left, which is the padding. Let's check it out in the box model. You can see for padding, there's 40 pixels on the left. And a reason the unordered list and ordered list has padding left is to allow space for those bullets. And again, we can see 16 pixels of margin top and bottom. So as you can see, browsers apply default styling rules. So let's now talk about CSS reset. It is very common to strip away the main default browser's styles to give us a blank canvas to work from. So the global reset looks like this. Using our universal selector, which selects every single HTML element, we apply a margin of 0 and a padding of 0. And doing this removes all default margin and padding. And we've already covered box sizing border box earlier. So doing this will strip away all the default margin and padding applied to every single HTML element. It gives us a blank canvas to work from. In addition to global resets, there are also element resets. And that would look something like this, where, for example, on our anchor tag, we remove that default underline by setting text decoration to none. And on our unordered and ordered lists, we remove the list style. That is, we remove those bullet points, as we're commonly using lists as a structural unit to build things like navigation bars. So let's jump into VS Code and apply the global resets. I'm back in index.html. I'm going to head over to app.css. I'm going to use the universal selector to select every single element. And I'm going to set margin to 0 and padding to 0. So let's check this out in the browser. So as you can see, it looks quite different. There's now no margin or padding applied to our elements. I'll just comment this out to remind you what it looked like before. So you can see here the default margin and padding applied. Let me just put it back. So doing this now gives us a blank canvas to work from. We can go now and add our specific styles. Now something interesting I want to highlight is that it looks like those bullets have been removed, even though I didn't apply a list style none. Those bullets are actually still there. They're just kind of overflowing the document. Let me show you. If I grab the unordered list and put a margin left of 100 pixels, you'll see that those bullets are still there. So we do need to make sure to apply some element resets, like list style none, to remove the bullets. Now another option, which takes a slightly different approach to a reset, is using normalize CSS. Normalize CSS creates uniform default styles for HTML elements without removing all styles like a reset does. Normalize CSS is a large CSS file that's added to your project. We grab it online, which I'm going to show you in a second. But I do just want to highlight this approach is slightly different to a reset. Instead of completely removing default styles like margin and padding, normalized CSS does have default styling, but its aim is to create a uniform experience across different browsers, because different browsers will sometimes have different default styling. So let's take a look at normalized CSS. All you do is head to Google and type in normalize CSS. Hit the first link, and we're taken to the normalized CSS page, where it says a modern HTML5 ready alternative to CSS resets. Normalized CSS makes browsers render all elements more consistently and in line with modern standards. So all we do is hit download, and it gives us this fairly large CSS file. I'm just going to hit Command A to select all of it, and then Command C to copy it to my clipboard. Let's head into VS Code now. So I'm back on the index.html file we were working in before. I've got our app.css file, which we did the reset. And now I just want to comment these out. I'm then going to go to the Explorer tab and create a new CSS file. We'll call it normalize.css. And then I'm just going to paste from my clipboard the normalized CSS file I copied before. And as you can see, it's quite a long file with 340 lines of code. Just to look at one line of it, I'm going to go Command F and search for an H1. You can see the font size is 2ms, which is 32 pixels. And you can see this comment above. Correct the font size and margin on H1 elements within section and article context in Chrome, Firefox, and Safari. So this is a good example of what normalized CSS is doing. It's setting a font size of 2ms, which is 32 pixels, across Chrome, Firefox, and Safari. So no matter which browser you're viewing your web page on, the H1 will always be the same size. To include normalized CSS in a project, you would come and add it just like you would any other style sheet. I'll grab the link tag by typing link, and normalized CSS is sitting inside our current working directory. So I'll just type norm to get normalized.css. Now it's important that this style sheet is included first. So any other styles that we add ourselves in app.css will override the styles set in normalized CSS. So let's check this out in the browser. So you can see normalized CSS has made a few changes to the document. To better see this, I'm just going to comment this out and refresh the browser. By doing this, we can see the default styles. And if I go on the body tag, you can see that there's a bit of margin of 8 pixels all the way around. And as we know from before, our headings and paragraph also have default margin. I'm going to turn back on normalized CSS and refresh. You'll see on the body tag, there's no longer any margin. But our heading and paragraph do still have some margin. If I turn off normalized CSS and go on comment, I'll reset styles in app.css, I'll refresh again, and you can see the difference where all margin and padding has been removed from every single element. So just to quickly summarize them, doing a CSS reset by setting margin and padding to 0 will strip margin and padding away from every single element. Whereas using normalized CSS does remove some default padding and margin, but its aim, instead of resetting everything, is to create consistent styles across different browsers. So some elements like the heading do still retain properties like margin. So let's wrap up by finishing off the summary card, setting global rules with the CSS box model. In this chapter, we learnt about CSS reset. We saw that we use the universal selector to reset styling rules that come default in the browser. The first rule we add is box sizing border box, and this makes setting dimensions more predictable, and margin 0 and padding 0, which removes all default margin and padding in the browser. Alright, I'm back inside our Quill project in the app.css file. We're going to go down to the universal selector and add in the CSS resets. We'll give it a margin of 0 and a padding of 0. And just a reminder from earlier, setting a margin and padding of 0 on the universal selector will apply a margin and padding of 0 to every single HTML element. Another approach was using the normalized.css file. I'm specifically going with this approach at this stage because I generally don't like including files where you don't really know what's going on behind the scenes. When you're first starting out, it's really important to know exactly what you're doing. So I'm using the CSS reset approach. But just be aware, the normalized CSS approach is pretty popular. So let's check this out in the browser. Alright, so it might not be so apparent exactly what's happened. So what I'm going to do is go comment this out, and we're going to look at each section of the web page. I'll save and refresh. So you can see by commenting this out, the first thing is that there's this margin on the entire body. Let's remove the comment, and you can see that all the content that's left aligned goes right to the edge of the page. That's the first thing this reset does. Now we've already applied some margin on our heading and margin on our paragraph to separate out these elements. You can see that down here in the hero section where we've applied margin bottom properties. So those margin properties will override the reset, so we're not going to see much change over here. However, scrolling down to here, there's now no margin between the heading and paragraphs. Just to show you that, I'll comment this out again and refresh. And you can see that there's a lot more spacing between this heading and this paragraph for each feature section. And that's because the heading has default margin. The same thing's happening down here in the CTA section. There's a gap here caused by the margin on this heading. So if I remove this comment, you'll see the reset is removing the margin on this heading, causing the button to move a lot closer to the heading. Let's take a look at the footer. I'm going to go and comment this out and refresh. And I want to focus on the unordered list element, which is structuring our different navigation menus down here. I'm going to go select the unordered list tag, and you can see we have some margin, top and bottom, and we also have this padding on the left. And the reason we have that is because in an unordered list, there would ordinarily be some bullets there. We've already removed those bullets with the list style none on the unordered list tag down here. And if you remember from earlier, I highlighted that our Quill logo and this sentence here, made with love in London, is horizontally centered in the page, whereas these social media icons and this small navigation list is kind of offset a bit to the right. And that's because the unordered list has this default padding on the left. So when I add back in the reset, you'll see that these actually center much better because that padding left has been removed. They also move a lot closer to each other because of the margin being removed from the unordered list. Now, usually in a project, one of the first things you come and do in your CSS file is add this line of code to give you a blank canvas to work from. Now, we obviously couldn't do that when we started out our CSS journey because we didn't know anything about the box model. So what we need to do now is look through our page and see anything we want to tweak slightly. There's two things I'd like to do. The first is to add a bit of margin between each feature section heading and paragraph, just to create a bit of space, because that space has now been removed from the margin that was there by default. And the second thing I'd like to do is add a bit of space between the Get Started Now and the Get Started button. Now, as I mentioned before, because you would ordinarily add this first, you wouldn't really need to do this, because you would already do this when creating white space, moving through your page top to bottom. So I just wanted to highlight, we need to think about this specifically now because we're adding our reset at a later stage. So let's go and add those two styles I mentioned. So I'll head over to our HTML file and scroll down to the features section. The headings I'm interested in adding a class to are these H3s over here. So I'm going to add a class of feature headings. Now I've already called this heading over here features main heading. So I put the word main there to distinguish it from feature headings over here, which are used for our H3s. I'm just going to copy this class and add it to all the H3s. I'll copy this class just so it's easier to select it. In app.css, I'll select that class out of curly brackets, and let's give it a margin bottom value of 20 pixels. Okay, so that's just created a bit more space between our heading and our paragraph. Now I put this class here because I generally like to have my classes match the order of my HTML. I have my section, main heading, feature heading, and then image, which corresponds to the order it appears in my HTML. But in principle, you could put these anywhere. Let's now go down to the call to action section, and I want to add some margin bottom onto this heading. Now again, we don't have any class for that, so let's go add that in our HTML. That's this H2 element here. I'll add a class of CTA heading. I'll copy that text, I'll head back to app.css, and under CTA card, I'll select the heading, and let's add a margin bottom of 30 pixels. Okay, nice. That's also created a bit more space between our heading and button. So by doing this reset, because we stripped away all the default styles, I've just gone ahead and tweaked a few things to just make it look a little bit better. But again, just to really hammer the point home, when you first create a CSS file, this is usually the first line of code you add. So the tinkering I just went through would just be part of the regular process of working with margin to create white space in your design. Now it's time to learn how to create a central layout structure for your web page by defining a main container. We'll be discussing the main wrapper container and the auto value. So what is a container? It is very common for a web page to have a wrapper which adds margin left and right as well as centers all the content. For example, on this web page here, you can see the main content is centered on the page. Behind the scenes, margin left and right applying to all of this content in order to center it. so that there's a bit of white space on the left and right. Now this would be considered a wide container. The content extends quite wide on the page. Let's have a look at another container. On this page here, you can see that this container is quite narrow. The content is a bit more contained within the center of the page, and there's a lot more white space left and right. So let's now talk about how we make a container. To create a container, a suitable width is chosen to prevent content from excessively stretching on larger screens. So let's say we have a screen which is 1600 pixels wide. What we would do is create a class called container and apply a width to it, say 1200 pixels. Because the container is going to wrap all the content, our web page would sit like this in the browser with the width of 1200 pixels, and all the content remains inside. So let's go play around with this in VS Code. Alright, so I've got a blank index.html file here, where I've already grabbed the boilerplate code. I've also linked up an app.css style sheet, which is currently empty. So the first thing I'm going to go do is add this container element. It's simply a div, which is going to wrap all our content. I'm going to give it a class of container. Let's go and give it a few elements. I'll give it an h1, which we can just call main heading, and I'll give it some paragraph text, and go grab some lorem ipsum times 3. Let's head over to the CSS. The first thing I want to do is just do our CSS resets, which we learnt about earlier. I'm going to add a margin of 0, a padding of 0, and just set box sizing to border box. Let's now go grab our container element. I'm going to give it a width of 800 pixels. I'm going to give it a background color so we can better see it. Let's give it a value of light blue. Alright, so let's check this out in the browser. So here's our container element, and you can see that all the content, the heading and the paragraph, is contained within this div, which I've made with the blue background. Now one thing I want to show at this point is how we can better see page dimensions inside DevTools. I'm going to right-click Inspect to open up DevTools. This icon over here, you can see says Toggle Device Toolbar. I'm going to click on that, and what this now opens up is a window where I can play around with the dimensions of the page. You can see that I can go to the edge over here and drag left and right, and the dimensions are changing up here. Later on in the course, when we talk about media queries, we're also going to come play around with some actual devices. So this view allows us to better see width and height values of the viewport we're looking at. So if I go and extend my viewport to the absolute edge, you can see that the width value is 1244 pixels. Knowing this is going to help us when we want to come and center this container. So let's now talk about centering the container. To center the container, calculate the remaining width and distribute the space to margin left and margin right equally. So in the example we were looking at before, we have a viewport width of 1600 pixels and our container width of 1200 pixels. So to work out the amount of margin left and margin right, we would do 1600 pixels minus 1200 pixels divided by 2 to give us 200 pixels. We would then update our container code to look like this, applying margin left and margin right of 200 pixels. This would then nicely center our container with 200 pixels of margin left and right. So let's jump back into VS Code and do it for our example. As a reminder of where we left off, our viewport width at full screen is 1244 pixels. Jumping back into VS Code, let's now go and add the margin left and margin right. So just like in the other example, we would take the viewport width of 1244 pixels, we would minus 800, and we would divide this by 2. This gives us a value of 222. So all we're going to do now is add margin left of 222 pixels and margin right of 222 pixels. So let's check this out in the browser. So as you can see, our container has nicely been centered, with 220 pixels of margin on the left and right. But I now want to show you a major problem with this approach. I'm going to open up DevTools, and I'm going to come grab the edge of the viewport here. As you can see, when I reduce the width, the container is no longer centered. It's because we've hard-coded these values, left and right. So obviously, if I were to apply the same equation of 1050 minus the container width of 800 pixels and divide that by 2, I'm not going to get the 222 pixels we applied left and right. So to fix this, we need to learn about an important value in CSS called auto. Auto is a value that enables the browser to automatically determine a property's size. It looks like this, where we have a property like height and the value auto. we've actually already seen this value apply behind the scenes with images. The property auto automatically applies to the other dimension when setting width or height to preserve the aspect ratio of an image. So for example, we've written CSS code that looks like this, where we would apply a width of 400 pixels and height auto would be applied behind the scenes. So although we didn't explicitly set height to auto, it is being applied behind the scenes so that when the image reduces or increases to 400 pixels, its height will also increase or decrease by the same proportion, so the aspect ratio is preserved. That is, the image won't distort. And we can also use the auto value on margin. In this case, it automatically calculates the remaining space inside a parent and is used to center a child container. So the auto value is being used differently to images. Inside the CSS code, it would look something like this, where we have a container of 1200 pixels, and instead of hard coding a value for margin left and margin right, we're just applying auto. And doing this centers the container, no matter what the width of the parent or viewport is. So let's jump into VS Code and fix up the problem we had before. I'm back in app.css, and I'm just going to remove the value we hard-coded and update it to auto. And I'll do the same for margin right. So let's now check it out in the browser. So back on the page, I'm going to open up DevTools, and I'm still inside this toggle device view. I'm going to come over to the far right, and I'm going to reduce the width of the page. And you can see that as the page reduces, the container is still staying centered. There's equal margin left and margin right being applied because of that value auto. Now, one last thing before we finish up is that using the shorthand margin property is concise and more common. So this is the setup we have, and this is the code we looked at before. Now, instead of applying margin left and margin right as two separate properties, it's more common to do this, applying a margin of 0 for top and bottom and auto left and right. This is the exact same as applying auto to margin left and right. And obviously applying a margin 0 top and bottom will not apply any margin top and bottom. Doing this is a lot more common and a lot more concise than applying margin left and margin right separately. So let's quickly update this in VS Code. I'm going to get rid of these properties and just type the margin shorthand, 0 for top and bottom, and also for left and right. And let's just confirm that this works as expected. So I'm back in the browser, and as I reduce the width of the page, you can see that it's still nicely centered. So let's finish off by starting to build our next summary card, responsive design with the CSS box model. In this chapter, we looked at how we can set up a main container. We have our browser shown in green, which let's say has a current width of 1600 pixels. In our CSS, we would then create a container. In this container, the width is set at 1200 pixels, and we center the container by applying margin 0 top and bottom and auto left and right, where the auto value is able to automatically calculate any additional space. So it would end up with a container looking like this. It would be centered and have a width of 1200 pixels. So let's go and now add a container to the Quill homepage. Our container is going to be applied like this. It's going to contain all the content, including the navbar. So let's jump into VS Code and apply this. So I'm back inside our Quill project on the index.html page. So the first thing we need to do is go add our container. Now it's best practice to actually make this its own element inside the HTML. So I'm going to add a new div just below the body tag. I'm going to give it a class of container. And then I'm going to move all the content from the body inside this main container element. So you can see now that this div with the class container is wrapping all the content. So let's jump into app.css. I'm going to scroll down just below the body and select the container. This is a common place to put it inside your CSS. Let's give it a width of 1200 pixels, and we're going to apply that neat trick of margin 0 for top and bottom and auto for left and right. So let's check this out in the browser. Okay, this is looking really good. You can see that all our content is now centered and we have some white space left and right. And let's also check this still works when I reduce the width of the page. I'm just going to come to the edge of the page here, and as I reduce the width, you can see that the content is still nicely remaining centered, with some white space left and right that's being automatically calculated. Now, one last thing I want to do just before we finish up is use this same trick to center this call to action card. Let's jump back into VS Code. In the index.html file, you can see we have this div with class CTA card, which is wrapping this content. So this div is acting as a container for the CTA card. Let's go down to that class, which is in our sections in our app.css page. Under CTA section, we have the CTA card. Now a width of 1000 pixels has already been applied. So all we're going to go do is add margin, 0 top and bottom, and auto left and right. And this will now center the card. So you can see now that this card has been centered with an equal margin left and right. And similarly, as I reduce the width of the page, the call to action card is staying centered because the auto value is automatically calculating the margin left and right to be applied to center the card. Now in a topic later on in the full course, I'll be doing a deep dive into centering elements and containers, because we will see later there are more modern and powerful methods with Flexbox, and I'll actually be updating how we center this card. Let's now take a look at how to restrict the maximum width of an element to ensure responsive design using max width. We'll be discussing the max width property, max width on block and inline elements, and max width design guidance. So this video is getting my more difficult step. The actual property max width we're going to look at is not too complicated, but we are entering into what is called responsive design, and it can be a bit more tricky to understand the best case for using maximum width. So what is maximum width? Maximum width ensures elements are responsive for different screen sizes. To better understand max width, let's first look at the width property we've already seen. The property looks like this, where the width of the element here is 500 pixels, and this sets a fixed width. And in this case, the width is 500 pixels, and it's fixed at this 500 pixel value. It won't go above or it won't go below. Let's now look at max width. The property looks like this, max-width, with a dimension value like 500 pixels. Now this sets an element's width that it won't exceed. So the element could be 500 pixels, which would be the maximum width, and it won't go above 500 pixels. But the major difference now between max width and width is the fact that if your browser reduces in width, the element will shrink less than 500 pixels. So width stays at 500 pixels no matter what the size of the browser, and max width stays at a maximum width of 500 pixels, but if the browser reduces in width, so will the element. Let's take a look at this inside VS Code. So I've set up an index.html file and grabbed the boilerplate HTML. I've also linked a style sheet app.css, which is currently empty. So inside the HTML, I'm going to go add a div, and I'm going to give it the class of container. I'm going to head over to app.css. I'm first going to use the universal selector just to reset all the default styles. So I'm going to set padding to 0 and margin to 0 to clear the default styles. Then I'm going to select that container class. I'm first going to give it a width of 1000 pixels, and I'll give it a height of 500 pixels. Let's then give it a background color of light blue. So let's check this out in the browser. You can see we have our light blue container here. Now what I want to do is drag my browser so that the browser width is less than the container width of 1000 pixels. And what you'll notice is that I can actually scroll across. You can see my scroll down the bottom. So because this is a fixed width, even though the browser is less than the container, the width of the container stays at 1000 pixels, which means that we can now scroll to see the full thing. I'm now going to change width to max width of 1000 pixels. And let's see the behavior here. So again, when the browser is the full width of my screen, the width of this element is 1000 pixels, because when we set max width of 1000 pixels, the element won't exceed 1000 pixels, but can go up to it. But the major difference now is that when I reduce my browser width, there's no scroll here. The width of the element is the width of the browser. And we can actually see this inside DevTools. If I inspect and click on the element and look at the box model, you can see it now has a width of 716 pixels, which is less than the 1000 pixels we set. And as I reduce and increase my browser width, you can see the width of the element is changing until we hit that 1000 pixels when it will stay fixed. Let's now talk about max width in the context of block and inline elements. Max width behaves differently depending on the display property of the HTML element. Let's talk about block elements first. For example, an h1 or a div. Block elements occupy the full width of their parent, and we know that width and height can be set. Looking now at regular inline elements, such as an anchor tag or span, they only occupy the width of their content. And we know for these, width and height cannot be set. And in order to set width or height, we need to change to inline block so we can apply min and max width. Now we've also previously looked at replaced inline elements. Those are inline elements like image and input, which don't wrap any content, but are replaced by something else, like an input field. Like regular inline elements, they only occupy the width of their content. And for these, width and height can be set, so we don't need to change them to inline block. Now block elements and regular inline and replaced inline elements are very different in terms of the width they occupy. And because of this, it's going to have a big effect on max width. So now we're going to go look at max width on each of these different kinds of elements. We'll start with max width on block elements. As we know, this sets the maximum width an element can be while it can still go narrower. We'll start by looking at the regular width property. On the left, this grey box represents a browser, which is currently at 1800 pixels. We're now going to set a block element with a width of 1200 pixels. The block element stays at 1200 pixels when the browser is wider. When we make the browser narrower, say 800 pixels, the element with a fixed width of 1200 pixels will now exceed the width of the browser. So block elements extends beyond the browser. Let's now compare this by looking at max width. We have our same browser initially at 1800 pixels. We set a block element with a max width of 1200 pixels. So the element will look like this. It will still be 1200 pixels, because block elements stay at 1200 pixels when the browser is wider, when using a max width property. Now the major difference between width and max width for block elements is when the browser is narrower, say 800 pixels. The element will adjust to the same width of the browser, 800 pixels. So the block element reduces when the browser is narrower. In the coding example we looked at earlier, we used a div to create our container. And we know that a div is a block level element. And because it's a block level element, when the browser is wider than the element, it stays fixed at the 1000 pixels we set. And when we reduce the width of the browser, the width of the block element also reduces. So let's now look at some max width block element guidance. Using max width on a main container ensures content does not go too wide on larger screens. Taking a look at this web page here, we can see the main container wrapping all the content in red. This container width stays at 1200 pixels when the browser is wider. So using max width on a main container ensures the content doesn't go too wide on huge screens. Now the primary benefit of using max width as opposed to width is that when on smaller screens, the container is able to scale down with the browser as it is not a fixed width. If this were a fixed width, the content would overflow and the user would have to scroll horizontally, which is not a good viewing experience. So let's check it out on this web page. I'm going to open up DevTools and I'm going to click on this div where it says container large. At the moment, this has a max width set at 80 rems. Now we haven't looked at units just yet. We'll be covering rems in the next topic. Now because I'm at full screen, the width of this container is fixed at 1280 pixels, so that the content doesn't go too wide on the screen. But as I start reducing the width of the browser, you can see at a certain point, the width of the content is starting to change, and is all contained within the browser. It doesn't overflow, and I can't scroll left and right. Now inside DevTools, we can actually change properties. I'm going to go change max width to a fixed width of 80 rems. So let's see what happens now when I start reducing the width of the browser. Because the container has a fixed width of 80 rems, or 1280 pixels, when I reduce the width of the browser, the container width is not scaling down. It's staying at 1280 pixels. And you can see what this causes is the content to overflow, where I now can scroll right. Now, as you can appreciate, this is not a good viewing experience. We want all our content to be inside our browser window. So that's the main use case of max width on block level elements. So let's now look at max width on inline elements. As we know, max width sets the maximum width an element can be while it won't go narrower. Let's again take a look at the width property first. We've got our browser, which currently has a width of 1800 pixels. We'll now define a width of 1200 pixels on an inline element. So for the fixed width property, the inline element width stays at 1200 pixels when the browser is wider. The exact same behavior as a block element. When the browser now goes narrower, say 800 pixels, the inline element remains at 1200 pixels, its fixed width value. So the inline element extends beyond the browser when it is narrower. And again, this is the exact same behavior so far that we've seen for a block element. Let's now compare this to the max width property on an inline element. We've got our same browser initially at 1800 pixels, and we apply a max width of 1200 pixels. So the inline element's width stays at 1200 pixels when the browser is wider. So far, the exact same behavior as a block level element. But here's where things get a bit interesting. When the browser reduces to a width less than the max width, say 800 pixels, the inline element actually remains at 1200 pixels. So the inline element extends beyond the browser when it is narrower. This did not happen for a block level element. The block level element reduced and matched the browser width. It's almost as if max width has no impact on an inline element. Let's go play around with this inside VS Code and discuss it a bit further. So I'm first going to go to unsplash.com to grab an image we can play with. I'm just going to go grab an image of a camel. I like this one over here. I'm going to click on it and copy the image address. Back inside VS Code, I'm just going to get rid of this div, and I'm going to grab the image tag. I'll paste in the link I just copied, and I'm going to go remove a whole bunch of stuff here we don't need after the question mark here. For the alt text, I'm just going to put camel. In app.css, I'm going to remove the container, and I'm now going to select the image, and let's first apply a width of 800 pixels. So let's check this out in the browser. So as you can see, the image of the camel is at 800 pixels. And as you'd expect, because this is a fixed width, when I reduce the browser width so that it's smaller than 800 pixels, the image cuts off and I'm able to scroll to see the rest. Let's now change width to max width. So as you'd expect, the image is currently 800 pixels wide as our browser is wider. When I go reduce the width of the browser, you'll see what I was talking about before. The image's width doesn't reduce like it did with the block element. It still extends beyond the browser, and you can see we can scroll. So what is going on here, and how do we fix this? So I'm first going to apply the fix, and then I'm briefly going to touch on it, as we're going to be talking about this a lot more in the next topic. I'm going to go add a width and set it to 100%. Now, we haven't actually spoken yet about percentage values, and as I mentioned, we're going to be talking about this a lot more in the next topic. But I do just want to show you the fix and explain a little bit about why it fixes the issue. So let's check this out now. If I reduce the width of the browser, you'll see the image does reduce, exactly like the behavior of a block element. So what have I done and why is it working? In simple terms, inline elements do not naturally expand to fill the width of their container. So setting width 100% ensures they do take up the full width available, allowing max width to limit their size. This is very different to block elements, which will automatically expand the width of their container, making max width effective without needing to explicitly set the width to 100%. It's kind of like block elements by default have width 100% applied to them in the background. Now, don't worry too much about this right now. We're going to be talking about it a lot more in the percentages section in the next topic. But I did just want to highlight that by default, when applying max width to an inline element like an image, when you reduce the width of the browser, the inline element won't shrink. We have to go and apply width 100% to make this work. So let's now discuss max width inline element guidance. Using max width on images creates a responsive layout. So for this page here, we have this large image in the center of the page. Now using max width will ensure that the image width stays at 1000 pixels when the browser is wider. Very similar to the use case for the container we looked at earlier, but it's just being applied to an image. Using the max width property as opposed to the width property ensures that the image scales down with the browser as it is not a fixed width. And as we saw, we will get this working later with percentages. You can't apply max width without also applying a width of 100%. Over the next few chapters, I'm going to be building up a width summary table, just to help see these different properties in relation to one another. Let's start with the property width. This sets a fixed width. For block and inline elements, the elements remain fixed when the screen size narrows or expands. An example of where you would use the width property on a block level element might be a sidebar, one of those side navigation bars you sometimes see on web applications. An example of an inline element where you'd use a fixed width are small images and icons. For the max width property, this sets an element's width that it won't exceed, but as we know, it can reduce. For a block level element, this will shrink when the screen size narrows, and an example of a block level element we apply max width to is a container. And doing this is very common, because we want our container to be responsive, so that when the screen size reduces, all the content inside with it also does. For an inline element, we saw that by default it won't shrink when the screen size narrows, and we had to do some extra work by applying width 100% so that it did reduce as the screen size narrowed. An example of using max width on an inline element is images, and again we saw this needs more work to achieve. Now in our Quill project that we've been working on, we'll be using both width and max width inside our project. So let's finish off by adding to our summary card responsive design with the CSS box model. In this chapter and in the next chapter, we're covering max and min width, and I'll be summarizing everything we learned in this table. In this chapter, we looked at the width property, which in CSS is defined like this, and this is when an element has a fixed width, and it's often used on small images and icons. We then looked at max width, which in CSS looks like this. Using this means an element won't exceed this width, but it can reduce, and max width is often used on containers and large images. So let's see how we can use max width on our Quill application to make the web page more responsive. I'm inside the app.css file, and I would like to highlight some areas we're currently using a fixed width, where we should replace it with a max width. If I scroll down, the first location is on the container. We're currently using a fixed width of 1200 pixels. So let's see what this is doing in the browser. So at the moment, that 1200 pixel width is nicely containing all the content. I'm going to open up DevTools just so we can see it. And as you can see, all the content is within the 1200 pixel container, which works well for larger screens like I'm on now. However, as we know from earlier on in this topic, is that when I reduce the width of the browser, the 1200 pixel container now exceeds the browser's width, which is causing the scroll over here. We don't want this behavior. We want everything inside the browser window. So let's go fix this by changing the container to have a max width of 1200 pixels. So looking at this now, when I reduce the width of the browser, you can see the container is also reducing in width. Before it was cutting off, now it's all within this window. But there is still a scroll here. This is actually being caused by another element. If I scroll down to the bottom, we've got this call to action card, and it also has a fixed width, which is ultimately setting the width of the entire web page. So let's go correct that in our markup. I'm going to scroll down to our different sections in the CSS file. In the call to action section, we have the CTA card, which currently has a fixed width of 1000 pixels. So let's update this to a max width of 1000 pixels. Let's go check out the impact. So I'm going to reduce the width of the browser, and as you can see, because the CTA card has changed from a fixed width to a max width, it's also reducing when the width of the browser reduces. So this is looking a lot nicer. Now shrinking the browser like this, I can only go to a certain limit. So what we're going to do to see much lower values is open up DevTools, and we're going to click on the toggle device toolbar over here. And this now allows us to reduce the width of the page to any value we want. So the main container is looking good. And the call to action down here is also looking good as we reduce the width. So the next issue we run into when I start reducing the browser's width to be a much smaller value is that this CTA card actually has some padding all the way around it. If I inspect the card, you can see we have this padding of 100 pixels top and bottom and 200 pixels left and right. So there's some left padding here of 200 pixels, which is now causing the total width of the page to be determined by the padding and the width of the card. You can see when I hover over the container, the card is overflowing. This padding issue we're going to solve later on in the course, when we start looking at responsive design. For now, I'm just going to turn it off because I want to highlight another issue. So the padding's now been turned off, but still there seems to be something causing our web page to overflow the container. I'm going to scroll up, and you can see it's now this image, and that's because our image has a fixed width. So let's go and fix that up. Back in VS Code, in the features section, we have a feature image with the width of 400 pixels. So let's go change this to a max width of 400 pixels. Let's see the impact of this. So nothing has happened, which seems a bit strange. If you remember from earlier on, the reason nothing has happened is because applying max width on an inline element, like an image, doesn't work. We also need to go apply a width of 100%, so that the image is able to scale down with its parent container. Now, this is something we're going to be talking a lot more about in the next topic when we talk about percentages. So don't worry too much about the details right now, just know that we have to add this in. So let's go check it out again. Okay, great. So now we can see that the image is reducing as we reduce the width of the browser. If I inspect it, you'll see that the image is now 235 pixels. So by setting max width on our main container, on our call to action card, and just temporarily disabling the padding, and also setting max width on the image, ensures that the elements will reduce with width as the page reduces with width. Now I do also want to highlight some elements which have a fixed width which we are not going to change. And these tend to be small images and icons. For example, our logo over here has a width of 100 pixels. We don't need to start playing around with max width there, as 100 pixels is really small, and almost all viewing experiences, even if on a small smartphone, will never go below 100 pixels. The other area we have a fixed width is on these social media icons. They have a very small width of 20 pixels. There's no need to add max width here. So we've looked at max width in detail. Let's now explore how to set minimum width for elements with min width. We'll be discussing the min width property, min width on block and inline elements, and min width design guidance. So like the previous chapter, the min width topic is also getting my more difficult stamp. So in the previous chapter, we had this slide about maximum width, where we looked at the width property and the new max width property. Let's now update this to look at maximum and minimum width. So I'll scoot over width and max width to make some space, and let's add in min width. The min width property looks like this, min-width, where the property is min width, and the value is something like 500 pixels. Min width is the opposite of max width. It sets an element's width that it won't shrink below. So if we have an element with a min width set at 500 pixels, the element's width won't go below 500 pixels. However, if the window expands, the element's width can exceed 500 pixels. I also just want to bring up this slide we saw previously, where we saw max width behaves differently depending on the display property of the HTML element, that is, whether it's a block element or inline element, and it's the same thing for min width. So let's update this orange sentence to now say max width and min width behave differently depending on the display property of the HTML element. So let's first take a look at min width on block elements. As we just saw, setting min width sets the minimum width an element can be while it can still go wider. Let's first compare this with the regular width property. We have our browser, which currently has a width of 1800 pixels. We now go add a block element and set its width to 1200 pixels. And again, we're looking at the case for a block element. If we now reduce the width of the browser to 800 pixels, because this element has a fixed width of 1200 pixels, it will remain at 1200 pixels. So the block element extends beyond the browser. Let's now compare this to min width. We have our same browser with the current width of 1800 pixels. We now set the block element's min width to 1200 pixels. And because we're using min width, the block element is able to expand the full width of the browser, 1800 pixels, so it goes wider. As you can see, this is very different to the width of 1200 pixels on the left. If we now reduce our browser to 800 pixels, our block element still has a width of 1200 pixels, because the minimum width our element has to be is 1200 pixels. So over here, the block element also extends beyond the browser. Let's play around with this inside VS Code. So I've gone ahead and created a new index.html file, and I've added the boilerplate, and I've connected an app.css style sheet, which is currently empty. So inside the HTML, I'm going to go add a div, and I'm just going to give it a class of card. Inside app.css, the first thing I'm going to do is just grab the universal selector and set all the padding and margin to 0, just so we have a clean slate to work from. I'll then go grab our card element. I'll give it a height of 200 pixels. For now, I'll give it a width of 800 pixels. And let's give it a background color of salmon, just so we can see it in the browser. All right, let's check this out. All right, so as expected, we have our card with the height of 200 pixels and a width of 800 pixels. And as we've seen previously, if I come and reduce the width of the browser, this card because it's using a fixed width, exceeds the width of the browser and overflows, which means I can now scroll right. So let's go compare this to min width. So I'm going to come update our code to change width to min width. So let's check this out again. So the major difference now is that because the width of our browser exceeds the width of 800 pixels, that is the min width we set, the element's width will go above the 800 pixels. Let's check this out in DevTools. I'll select our element, go down to the box model, and you can see its current width is 1280 pixels, which is more than the 800 pixels minimum width. And as I reduce the width of the browser, you'll see the width also reduces until we get to 800 pixels. So once again, the element's width will overflow, and I can scroll right on the page. So let's now look at some min-width block element guidance. Min-width is useful for maintaining a section width in a grid layout so it does not become too narrow. Grid layout is something we haven't covered yet. So this guidance won't seem so relevant now, but it is something you should keep in your back pocket. An example of this is used in Duolingo's courses. This middle section has a min-width. This is an important section of the page, as it's where users interact with when going between different topics. When you reduce the width of the browser like this middle section won't go below a certain width to remain user-friendly. Now again, this is what we call a grid layout. There are 3 columns here. The middle column is what we're currently looking at, but there is a column left and right, and this is being achieved with CSS Grid. So you would use the min-width property inside CSS Grid, something we'll be looking at in a later topic. So let's have a look at the Duolingo page in the browser. As I reduce the width of the page, you'll see the middle section does reduce its width as I reduce the width of the browser. However, when I hit a certain point, it stays fixed. So let's now take a look at min-width on inline elements. So again, this sets the minimum width an element can be while it can still go wider. So for this example, we're going to be looking at a span with some text inside of it. As you know, a span is an inline element. We'll first be looking at the case where there's no width set on the span. Let's first look at an example of a span which has the text short text. And in this case, because there's no width set, the width is determined by the content itself, as it's an inline element. And if we have some longer text, again, the width is determined by the content. Let's now go and apply a fixed width of 300 pixels to the span. And to do this, you'd also need to change the display property to inline block. Because we've seen previously, you can't set width or height on an inline element. You have to change it to an inline block element. Because we've set a fixed width of 300 pixels, both the short text and the longer text have a width of 300 pixels. And in the case of the longer text, the text is now wrapping onto a second line. Let's now look at the min-width property. So for the short text, it remains at 300 pixels. But for the longer text, because it's now the min-width set at 300 pixels, it is allowed to go wider. So the min-width sets a minimum width. Let's go play around with this inside VS Code. So I'm back inside our index.html file. I'm just going to go get rid of this div, and I'm going to grab the span tags. I'm going to give it the class noWidth. I'm going to add the text heated, warm swimming pool. I'm going to copy this span and paste it below, and just change the text to something shorter, like Wi-Fi. Inside app.css, I'm going to remove the card. I'm going to select the spans, which was the class noWidth. I'm going to give it a background color of light coral. As I mentioned previously, we have to change the display property to inline block so that we can later go apply width properties. And just to make it look a bit nicer, I'm going to apply text align center. So as expected, the width of each of our spans is just the width of the content itself. All right, I'm going to jump back into index.html. I'm just going to copy these, paste them below, and change the class of both of these to width. I'm then just going to do something a bit hacky and put a BR tag between these two sets, so it'll force these new spans onto a new line. In app.css, I'm now going to copy this previous style, and I'm just going to update the class to just be width. I'll change the color to light green, and I'm now going to go add the width property and set its value to 100 pixels. So let's check this out. So you can see by setting a fixed width, the text inside this first span now wraps, so it fits within the width of 100 pixels. And because the width of Wi-Fi was less than 100 pixels, there's now additional space left and right of the word Wi-Fi. All right, so finally, let's go add our third case. I'll grab a line break tag just to separate the spans. I'll copy these, and I'm now going to change the class to be min-width. In app.css, I'm going to copy this style. I'm going to update its name to min-width. Let's change the background color to light sky blue. And now instead of width, let's set min-width of 100 pixels. Let's check it out. All right, so let's open up DevTools to see what's happened. This first span over here has a width of 189 pixels. So the text content is setting the width here. The min width is set at 100 pixels, but remember, it can exceed this. And because the text content is longer, it's going up to how long the text content is. With the Wi-Fi example, we can see that if I click on this one above, the width of that is 27 pixels, which is just the width of the content. But because we've now set a min width of 100 pixels, the span now goes 100 pixels. Now, of course, we could also set a min width value larger than the min width value of the text content. It's currently at 189 pixels. Let's go change this to 200 pixels. So you can see now both of these spans have a minimum width of 200 pixels. So let's look at some min width inline element guidance. Min width is sometimes useful for spans as it ensures text does not become too narrow and improves visual consistency. I actually struggled to find a good example of this, so I'm going to show you an example where you could use it. This is from the Etsy webpage, where at the bottom of a product page, there are different tags for related products. The min width could be used on these tags, like this small gift tag over here. Using the min width property would make these tags just look a bit more visually consistent, and not have these odd tags with smaller text looking a lot smaller compared to the rest. Now in the previous chapter, we had a width summary table. So let's now go and add to this with the min width property. For its description, it sets an element's width that it won't shrink below. Looking first at when it's a block element, for its browser size behavior, it will expand when the screen size widens. And we saw an example of this was inside a grid section, which we haven't covered yet. For inline elements, the content won't wrap onto another line. And a UI example of this we saw were tags, which to be honest are just less common, but I did want to provide some example. Now the width and max width property are just a bit more commonly used, and are what we will be using in our project, as you've seen in previous chapters. We won't actually be using the min width property. Now I know this is all a lot to take in with max width and min width. My general advice would be focus on max width. It's a lot more important and it's used a lot more. And don't worry too much about min width. Let's wrap up by continuing to add to our summary card responsive design with the CSS box model. In this chapter, we learnt about min width. So let's go add it to our summary table here. In CSS, the property looks like this, and min width means an element won't reduce in width, but it can exceed. And we saw it's often used for grids, which we haven't yet covered. On to the last chapter of this topic. We'll now learn how to control the maximum and minimum vertical size of an element using max and min height. We'll be looking at the max and min height property and max and min height design guidance. So just like the previous chapters on maximum and minimum width, I'm also going to be giving this chapter my more difficult stamp. So let's take a look at the maximum and minimum height properties. We'll first start with fixed height, which has the CSS property like this, and this sets a fixed height. So we have our element over here. It has a height of 500 pixels, and this is fixed at 500 pixels. Looking now at max height, the CSS property looks like this, max-height, and this sets an element's height that it won't exceed. Looking at our element, we have a height of 500 pixels, and the element will never go above 500 pixels. However, just like max width, it can reduce in height. Now we're going to see soon there's just a bit more going on with max height compared to max width. So this is a slight oversimplification, and we will be going into more detail soon. Next up is min height. The CSS property looks like this, min-height, and this sets an element's height that it won't shrink below. We have our element here at 500 pixels, and the element won't go below 500 pixels. However, the height can expand beyond 500 pixels. Now, before we specifically talk about maximum and minimum height, I want to discuss maximum and minimum properties in general. Max and min width are more commonly used compared to max and min height due to their role in creating responsive layouts. So if we look at all our maximum and minimum properties for width and height over here, on the far left, max height is least frequently used, whereas max width is the most frequently used. And that's because for responsive layouts, we're moving horizontally from browsers on desktop, tablets, and mobiles. Now with all these properties, all are more commonly applied to block elements, especially for min and max height. So in this chapter, I'm not going to be going through min and max height for block and inline elements. I'm just going to be focusing on block elements when using the max and min height property. I promise I'm not trying to cut corners, I just want to focus on what's important. Max and min height aren't that frequently used, and they're even less frequently used on inline elements. So in this chapter, I'm just focusing on max and min height on block elements. Now, before we start talking about max height in detail, I need to flag the big difference between max width and max height. Max width and max height behave in fundamentally different ways. For max width, it's based on its container, so it applies even without content. In a previous chapter, inside VS Code, we created a div and applied the max width property, and we saw that when we reduced the width of the browser, the width of the div also reduced. This wouldn't work for max height. It's because max height only applies when content exceeds the limit. So let's jump into VS Code and I'll show you what I mean. Alright, so I've gone ahead and set up a new index.html file and grabbed the boilerplate and linked an empty style sheet app.css. Inside the body, I'm going to create two divs. I'm going to give the first div a class of box1 and the second div a class of box2. Moving on to app.css, I'm first going to grab the universal selector and just clear all the padding and margin. I'm then going to select box1. I'm going to apply a width of 1000 pixels, a height of 400 pixels, and a background color of light blue. I'll copy these styles, change box1 to box2, and I'll just give this a background color of light salmon. All right, so let's check this out in the browser. All right, so as expected, we have two boxes, both with 1000 pixels wide and 400 pixels high. I'm now going to go change box1 to be a max width of 1000 pixels and box2 to have a max height of 400 pixels. I'll refresh and watch what happens. Box1 is still there and has a max width of 1000 pixels. And if I were to reduce the width of my browser, the width of the box would reduce. But box2 has entirely disappeared. And like I touched on earlier, we actually need content inside box2. At the moment, there is no content. It's entirely empty. If I go just add a paragraph, let's get lorem times 4. I'll refresh, and you'll now see that box2 is back, and the height is just being set by the height of the content. If I add some more content, so I'll just get rid of this lorem, and I'll now do lorem times 20, and refresh, you'll see what's happening now. The content is overflowing, but the max height is working. Box2 has a max height of 400 pixels, which you can see in the salmon color. So let's take a look at this in diagrams. I'm first going to start with a piece of content, shown in green here. Like we just saw, this could be something like paragraph text. The content's height is 500 pixels. Note, this is not me setting a height, it's just the height of the content itself. This content lives inside a container, like a div we just saw. And the height of the container is also 500 pixels. And that's because the container's height is set by the content height. Let's now go apply a max height of 300 pixels, which is less than the content height of 500 pixels. Our content remains the same at 500 pixels because we're applying the max height onto the container. So we end up with the container with a smaller height of 300 pixels than the content. And you can see the content overflows the container. So let's go play around with this again inside VS Code. I'm going to get rid of box1, and in the styles, I'm also going to get rid of box1 over here. So as we just discussed, we have our content, this paragraph text, and let's go check its height in DevTools. It currently has a height of 558 pixels, and this paragraph lives inside our div container, which we've set to have a max height of 400 pixels. We can confirm that in DevTools. If I grab the div, you can see it has a height of 400 pixels. So we're saying that the maximum height the div will go to is 400 pixels. Looking back at our paragraph, if I change the div to have a max height larger than 558 pixels, the div will then just be the same height as the paragraph. So let's go change this to something like 1000 pixels. I'll refresh, and you'll see now the div container is the same height as the content. Because again, the maximum height it can go to is 1000 pixels, but the actual content inside the div is currently at 558 pixels, so it won't exceed that. Changing this back to 400 pixels, you can see again the content is overflowing the container. So this brings us to a new CSS property, which can be used in circumstances like this called overflow. This controls what happens to content that overflows an element's box. It looks like this. Overflow is the property, and in this case, hidden is the value. There are 4 values for the overflow property: visible, hidden, scroll, and auto. Visible is just the default property. It just means that overflow can happen. Hidden clips the content, so any content overflowing will be cut out. Scroll introduces a scroll bar that will always be present, even if there is no overflow. And auto is a scroll bar only when necessary. That is, only when the content actually overflows. So let's go play around with these in VS Code. So let's go grab our overflow property. The first value, which is the default value, is just visible. I'll refresh and you'll see nothing happens. Let's change this to hidden, and you'll see now the content that overflowed is now just cut out. Let's change it to scroll. I'll refresh, and you'll see this introduces a scroll bar for the box, and I can scroll and see the rest of the content. I'll change it to auto, and this too will introduce a scroll bar on the right over here. Now, it is more common to use overflow auto as opposed to overflow scroll, as overflow auto is a bit more versatile for other circumstances. So let's now look at some max height guidance. Max height is used when you want to ensure elements do not exceed a certain height. A good example of this is on a modal window. A modal window has a max height, and you can use CSS to get a scroll. So in this example, this modal window, otherwise known as a pop-up, has over 1,000 reviews. Now, for a good viewing experience, we wouldn't want to show all those reviews on the pop-up. We want to ensure the pop-up doesn't exceed a maximum height, so it fits nicely inside our browser window, but then we also want to be able to scroll inside of it. So we could use the property overflow auto. If we didn't set a max height, this pop-up would have a massive height and cause our web page to also have a huge height. Let's now take a look at min height. I introduced this diagram not too long ago, where we had our content at 500 pixels and a container also at 500 pixels, as the container's height is being set by the content height. Let's now go and apply a min height of 800 pixels to the container. For the content, it's still at 500 pixels, but the container now has a minimum height of 800 pixels. So for minimum height, the container is now larger than the content. So let's go play around with this inside VS Code. I'm going to remove this max height value, and I'll refresh. So the height of our content is setting the height of our salmon colored container. I'm also just going to get rid of the overflow property, as we don't need it anymore. Let's go add a min height, and we'll set it to a value of 800 pixels. So you'll see now the minimum height of the container is set at 800 pixels, which is now larger than the height of the content here. Let's open up DevTools again. I just want to check the height of this paragraph one more time. So it's 558 pixels, which is less than the minimum height value we've set at 800 pixels. Let's now go set a value less than 558 pixels. I'll set a minimum height value of 400 pixels. Let's refresh, and you'll see the content still nicely fits inside the box. And that's because the minimum height of the container is 400 pixels, but it can expand beyond this. And in our case, the height of our content is 558 pixels, and that's now setting the height of the container. This is the complete opposite of max height. If I change this to max height and refresh, the maximum height the container will go to is 400 pixels. But because our content is at 558 pixels, it's overflowing. So that's the major difference between min and max height. So let's look at some minimum height guidance. Minimum height is used when you want to ensure elements maintain a minimum height regardless of the amount of content. A good example is this card over here. This will maintain a minimum height even if there is less content. This card is a component, and it's used throughout the application. Now, the amount of text in this card varies. The heading may only have 2 lines, and if you didn't set a minimum height, the height of the card elsewhere would be different. So if you wanted to ensure consistency of the height of this card, you would set a minimum height. Now, just like in the width chapter, I'm going to be providing a height summary. We have this table over here. The first property we looked at was height. This sets a fixed height for both block and inline elements. It remains fixed when screen size reduces or increases in height. An example of where we'd use a fixed height value on a block element is a navbar, and it's something we're going to be implementing in our project later. For inline elements, you could use a fixed height on small images and icons. In our project, we're just applying it to the width. The max height property sets an element's height that it won't exceed. In this chapter, we only looked at block elements. For the browser size behavior, max height limits the content height, and overflow occurs if content exceeds the value of max height. And an example of using max height is on a modal. For the minimum height property, this sets an element's height that it won't go below. We looked at block elements. For min height browser size behavior, the container can expand if content is more than the min height value. And an example is on section containers, like the card we just saw earlier. In our Quill project, height and minimum height are the properties we will use in our Quill project. Now, we can't implement them just yet, as we still need to learn a few more things. But let me show you where we are going to add height. So we're going to be adding a fixed height to our navigation bar at the top here. Inside DevTools, this nav bar currently has a height of 162 pixels. And this is just being set by the content, which is the logo and the 2 buttons. In the Flexbox topic, we're going to be moving our buttons to be in line with the Quill logo, and then we'll go add a fixed height. We just can't do it now because these buttons are currently under the logo. So for the nav bar, we'll be adding a fixed height. Now in the next topic, we're going to be learning about units, and we're going to be applying a special unit that ensures the height of this hero section is always above the fold. That is, it's always above the bottom of the browser. In addition to that, we're also going to be applying a min height value so that if the height of the browser window reduces very small, not all the content is pushed into a very small space. Rather, it will overflow. So I just wanted to give a bit of a taste of where we're going to be using height and min height in our project, but don't worry too much about it for now, as we do need to cover some other concepts first. Let's finish off by completing our summary card, responsive design with the CSS box model. In this chapter, we looked at max and min height. Just like max and min width, I'm going to be summarizing this all in this table. We started by looking at the simple height property. In CSS, it looks like this, and this is when an element has a fixed height. An example of where we can use this is on a nav bar. We then looked at max height. In CSS, it looks like this, and max height is when an element won't exceed the height, but it can reduce. A common use case we looked at were modals or pop-ups. We then looked at min height. In CSS, it looks like this. Min height means an element won't reduce height, but it can exceed. And we saw a common use case was on section containers. That was a big one and a lot to take in. So congratulations on finishing the CSS box model topic. Before we move on to the next topic, I'd really appreciate it if you could take 10 seconds to share your feedback on the course so far in the comments below. This course has taken nearly 12 months to create. Countless hours have been spent clearly structuring each concept so it's easy for you to understand, designing custom illustrations, handwriting each letter for that cool animation effect, and video editing hundreds of hours of footage to ensure you get a top quality learning experience. It's been a lot of work with a lot of late nights and early mornings. Here's some snaps of me at 5 AM with my son watching Thomas the Tank Engine while working on this video. Your feedback keeps me motivated. These amazing comments I've received on my HTML full course really help me to keep going. So please drop a comment below and subscribe to the channel. It would mean a lot to me. With that said, let's get back to it. It's time to take our CSS knowledge to the next level by learning about CSS units. CSS units are essential in web design, defining the sizing and spacing of elements on a page. We'll be taking a deep dive into the various units available to us, from absolute units like pixels to relative units like percentages and rems, and get a solid understanding of how to and when to use each unit type to build more responsive web pages. Let's start by exploring the basics of fixed and flexible measurements with absolute and relative units. We'll be discussing absolute versus relative units and the importance of relative units. So let's start off by talking about absolute and relative units. Relative units are essential for responsive web pages so elements can dynamically adjust for different screen sizes. Now, we briefly touched on absolute and relative units earlier on in the course in the CSS text topic. So let's quickly recap what we discussed there. We first spoke about absolute units. This is when the size is fixed and does not change in relation to parent elements. Examples of absolute units include pixels, points, inches, centimeters, and millimeters. Points, inches, centimeters, and millimeters are uncommon in web development. Point is an absolute unit that's commonly used in the print industry, and inches, centimeters, millimeters are units that are used in the real world. Now, throughout this topic, we're going to be looking at a whole bunch of relative units. However, the pixel, which is an absolute unit, is still used for specific cases. We're not going to be totally throwing it away. We are still going to be using it. So what are relative units? Relative units is when the size is based on the size of a parent element and adjusts proportionally to changes in the parent element. Common relative units include percentages, ems, rems, vh, and vw. And we'll be looking at each of these throughout this topic. Relative units are commonly used in CSS because they dynamically adjust depending on the screen size, which is really important for responsive design. That is, design that caters for all different screen sizes, like desktop, tablets, and mobile. So just to highlight the difference between absolute and relative units, I'm going to use this analogy. What you see over here is a photograph of how I proposed to my wife. We went out for a nice Mexican dinner and came back to her parents' house, where I got her family to put a whole bunch of balloons with string coming off them and attach photographs of us during the time we were dating. Yes, I was a bit of a romantic. Anyways, the reason this is relevant is because it's actually a great way for me to show you the difference between absolute and relative units. So here's the balloon with the string dangling off it and attaches a photograph of me and my wife. We're going to say the balloon is the parent, which has this height, and the photograph is the child, which has this height. Now, if I increase the size of the balloon, we can say that the parent increases. Now, the balloon increasing in size has absolutely no effect on the photograph increasing in size. It remains the same size, so there's no change in the child. This is how absolute units work. We can adjust parent elements without having any direct effect on child elements. I now want to compare this to putting an elastic band around the balloon. The balloon is this height, and again, we're going to call it the parent, and the elastic band is currently this width. And in this case, the elastic band is the child. Now, when we blow up the balloon and increase its size, the parent increases, but also the elastic band has now increased, so the child increases. This is an example of relative units. The size of the parent directly impacts the size of the child. So let's see relative units in action. On the left, I have a desktop design, and on the right, a mobile design. On the desktop view, you can see the main container with the text and buttons has a lot of space left and right. However, on the mobile design, you can see now there is no space left and right, so the main container widens. Another example of relative units is this space between the callout at the top, number 1 team building software, and the main heading. This would be something like padding. And while a little bit harder to see, on the mobile version, the padding reduces to tighten up the content on the mobile to improve its readability. And something very noticeable is on the desktop view, our main heading is very large, whereas on the mobile view, the font size reduces. So here are 3 really good examples of where we would use relative units: on containers, box model properties like margin and padding, and font size. And we'll be looking at how we apply relative units to each of these and more throughout this topic. So let's start building out the summary card for this topic, CSS units. Now, we haven't actually looked at any relative units yet, so all I want to do is list out common places we continue to use pixels. Pixels are still used in the following areas: border radius, border, letter spacing, logos and icons, max width, and shadows, which we'll be looking at later on in this course. Besides the max width property, all of these properties tend to be much smaller values. For example, it's not common to have large border values, something like 5 or 6 pixels. Because these values are so small, we continue to use the pixel because using relative units really has no impact on them. Now, over the next few chapters, we'll continue to add to this summary card of common use cases of each CSS unit. Now, inside our Quill project, I just want to highlight some of the areas that absolute units are causing some issues. We're going to see this by opening up DevTools and clicking on this device toolbar over here. I'm just going to make some more space. And let's start with this text up here. If I reduce the width of the browser, so I'm moving towards a mobile view, you can see this text is just way too large. And that's because we're using an absolute value of pixels. We need our text size to reduce as the size of the browser reduces. Another issue is that the content is butting up right against this left edge. You can see that over here, and other headings and paragraphs over here. This doesn't look great. We need a little bit of space left and right. You can also see our images are not reducing with width. They're staying the same size. We need our design to reduce the image sizes as the width of the browser reduces. And the final issue, which we've seen before, is that our call to action over here is looking very weird because of the left padding over here. So we also need to fix some spacing issues like padding and margin. Now, throughout this topic, we're going to be using relative units to make our homepage more responsive. Next up, let's take a look at our first relative unit, percentages. We'll be discussing what are percentages design guidance, and common percentage value use cases. So what are percentages? A percentage is a unit that is always relative to some other value. There are two main use cases in CSS. The first is relative to a parent, and these are commonly used on CSS properties like width, height, margin, and padding. Using percentages relative to a parent is very common. Looking at an example of this, in green I have a container. Its width is 1000 pixels, and its height is 600 pixels. If we were to place another container, like a div, inside of this container, the red container is now a child of the green container. We could then set the width and height of this red box relative to its parent dimensions. So we could do something like this. We could set the height of the box to 50%, which would be 300 pixels, 50% of 600 pixels. And we could set the width to something like 40%, which would be 400 pixels, 40% of the 1000 pixel width of the parent element. So we're using percentages for the width and height of our child element, where the final pixel value is being calculated based on the width and height of the parent element. Another use case of percentages is relative to the element itself. You can use this on a property like line height. I do just want to flag that there are very few elements you can do this with, so don't worry too much about it. Using percentages relative to a parent is way more common. But let's look at this. If we have some text, this text would have a height which is determined by its font size. Let's say it has a font size of 20 pixels. We could then apply line height as a percentage of the element itself. So let's say 200%, which would be 40 pixels. We're using the font size of 20 pixels and doubling it to apply line height of 40 pixels. Let's check these out inside VS Code. So I've got a blank index.html file, and I've gone ahead and connected a blank style sheet app.css. Inside the body, I'm going to create a div, and I'm going to nest another div inside of this. We'll give the parent div a class of parent, and we'll give the child div a class of child. In app.css, I'm going to select the parent, I'm going to give it a height of 500 pixels, and for now let's give it a width of 800 pixels. And let's give it a background color of light blue. Let's go and select the child. We'll give it the same height of 500 pixels. For now, I'm going to give it a fixed width of 600 pixels. And let's give it a different background color of light salmon. All right, let's check this out in the browser. Okay, so we have our blue parent over here and our salmon colored child over here. As we know from the HTML markup, the salmon colored box is a child of the parent. Now I want to go change the width value of the parent. Let's make it 1000 pixels. I'm going to refresh. You can see that the parent width has increased, and as expected, nothing's happened to the child because we're using absolute units. I'm going to change this back to 800 pixels, and now instead of width 600 pixels, let's go change this to 50%. I'll refresh, and now you can see what's happened. The child element is now 50% the width of the parent, which would be 400 pixels. Let's check this out inside DevTools. I'll select the child element, and on the box model, you can see it's 400 pixels wide. Now here's where the magic happens. If I come and change the parent width, let's now make it 1000 pixels, the width of the child will still be 50%. So let's refresh. So you can see now that the width of the child has gone to 500 pixels. That is, the child width is directly proportional to the parent width. Let's now have a look at the other case where we could use percentages relative to the element itself. And as I mentioned, this is less common, but I still want to show you. I'm going to go remove these divs, and I'm just going to add an h1 tag. Let me put some text. In app.css, I'm going to remove these styles, and I'm just going to select the h1. Let's give it a font size of 20 pixels. I'm going to give it some background color of light green, and let's apply a line height value of 200%. So we would now expect a line height value of 400 pixels. Let's check this out in the browser. So you can see over here is our text, and there's height above and below. And if we inspect this in DevTools, we can see that the height of the element is now 40 pixels. That is 200% or double 20 pixels. So let's now take a look at some percentages guidance. Percentages are used in conjunction with max width on main containers so that the web page is fully responsive. Let's have a look at this page over here. We can see the container in red, and this container would have a max width property where the value would still be in pixels, which is very common to do. When we reduce the width of the browser for a viewing experience on tablet or mobile, we want to ensure the content inside the container is not right up against the edge of the screen on the left and right. If you remember, the max width property just sets the maximum width, where the content can still reduce. So we need a way to ensure that there's still space left and right of the main container. We have our body over here in green, and you can see our container in red. So in addition to the max width property, which is mostly there to control maximum width on larger screen sizes, we apply a percentage of the body when the screen is smaller to prevent the content going right up to the edges. So you can see we have some spacing on the left and right of the main container. So let's see this in action. I'm currently on this home page on my desktop, and you can see there's a lot of space left and right, as all of this content is in a container. And this is being controlled by the max width property. Let's check it out in DevTools. Over here we have this div with the class container. So I'm going to click on that. The container has a max width of 75 rems. We're going to be talking about rems soon, which is a relative unit. Now I'm going to come turn this max width off, and you'll see that the content stretches much further. The max width is here to ensure that on larger screens like a desktop, the content inside the container doesn't stretch too far horizontally. I'm going to come and reduce the width of my browser, and you'll see that the container on the left and right reduces in space, because on smaller screen sizes like a mobile, we need our content to take up more space, as space is limited on smaller screen sizes. However, you will note that there is still a bit of space left and right, and that's there to avoid the content butting up left and right on the edge of the browser, because that would not be a good viewing experience. So max width has nothing to do with this now. This is now controlled by a percentage value. I'm going to go back to the full screen. On the container, if I turn width 95% off, you can see nothing happens on the desktop view. I'm going to turn it back on, and let's go toggle the device. I'm going to reduce the width, so we get to a device like a mobile. I'm also just going to remove some styles from this app media. This is called a media query, and it's something we'll be discussing later on in the course. I'm just going to scroll down on the page to this heading and paragraph here. Watch what happens when I turn the width off. You'll see the content moves a lot closer to the left and right of the screen. I'm just going to toggle it on and off so you can see it again. Now I'm going to turn the width back on, and I'm going to change it to another value, like 70%. And you can see now that there's a lot more space left and right. This is not something you would do, as this doesn't look great, but I just wanted to show you that for smaller screen sizes, we now introduce the width property, in addition to the max width property, but we use a percentage value on the width to ensure that there is still a container which has space left and right on smaller devices. Now this is something we're going to be implementing on our Quill project, and I'll be discussing it in more detail there. So don't worry too much about it now. I just wanted to show you that percentages are commonly used on a main container, and they're specifically used to ensure that there is still a container with spacing left and right when our page is on smaller devices like mobile. So let's look at some more percentage guidance. Percentages are used in conjunction with max width on standalone images so that the web page is fully responsive. Here's the Notion homepage, and you can see we have this large standalone image over here. To avoid the image stretching too wide on desktop screens, we apply the max width for larger screens. Now this works well on larger devices like a desktop computer, but there is some extra work we need to do for mobile. On the mobile device, we have our main container here in green, and for our image, in order for it to be responsive, we need to also set the width to 100% on smaller screens so the image scales to the full width of the container. So on this image, we'd have both the max width property, which is there to prevent the image stretching too wide on larger screens, and we would also apply width as 100%. And this ensures the image reduces in size as the width of the browser reduces. Now, just a quick reminder about why we need to do this. It's because an image is an inline element. So we're going to be looking at an inline element reminder. Inline elements will extend beyond the browser when it is narrower. So let's say, for example, we have our image with a max width of 1200 pixels. We have our browser, which is currently at 800 pixels, less than the max width of 1200 pixels. For an inline element like an image, it doesn't scale down like a block element would. It extends beyond the width of the browser, so it would remain at 1200 pixels. Now, one thing I want to highlight is that for standalone images, we're applying a width value of 100%. All that this is doing is ensuring that the width of the image scales at the same proportion as the width of the main container. Now a block element would do this automatically, but for inline elements, we need to explicitly set width as 100% to ensure that it does scale down as the width of the browser reduces. I also just want to note that in the previous guidance, we were setting main container widths to a value less than 100%. That was to ensure that there was space left and right of the main container. In this case, we're setting the image to exactly 100%, so it scales in direct proportion with the main container. There are going to be quite a few percentage values flying around as we move through this guidance. Towards the end of this chapter, I am going to provide a summary of the different values we use in the different use cases, so just stick with me. So let's check out an example of this behavior. So I'm on this web page here, and if I scroll down, we have this large standalone image. As I reduce the width of the browser, you can see that the image scales down. I'm going to extend the browser back to the full width of my screen, and let's open up DevTools and see what's going on here. I'll select the image, and you'll see we have this max width property of 1012 pixels. I'm just going to turn that off, and you'll see the image goes quite a bit larger. So again, the max width property is there to ensure the image doesn't scale too large for bigger screen sizes like a desktop. I'm just going to pop it back on. You can also see over here the width property set to 100%. I'm going to turn that off, and let's see what happens as we reduce the width of the browser. You can see the image doesn't reduce in size now. And as I explained earlier, because an image is an inline element, it now overflows, and I can scroll right on the page to see the image. So that's what the width 100% is doing. It's ensuring that as you reduce the width of the browser, the image scales in the same proportion. So let's turn it back on, and you'll see now the image is scaled nicely. The next percentage guidance is that it is common to set images inside a grid or flex container to 100% so it fills the cell and adapts responsively. So far in this course, we haven't looked at grid or flex, and we still need to learn about it, but I did just want to provide this guidance now. On this page, we have a grid layout, shown by these two green boxes. The grid layout is 2 columns and 1 row. The image on the right is inside a grid cell, which acts as a container. And as you can see, the image nicely fills the container. And that's because we're setting a width on the image to 100%. 100% of the parent element, that is, its container. So let's go check out an example of this. So I'm on the Notion homepage towards the bottom. What we have over here is a grid layout. We have 2 columns and 1 row. Let's open up DevTools, and I'm going to select the image in here. You can see the width is currently set to 100%. I'm going to turn that off, and you'll see the images go huge. I'm going to open the image in a new tab, and you can see this is the actual size of the image. In order to scale it inside this grid cell, we need to set the width to 100%. Another example of this is using these icons over here. This is a much larger grid. It's got 7 columns and 3 rows. I'm going to go inspect the image. I'll click on this one here. And again, you can see we have width 100%. Let's go check out the actual size of this image. I'm going to right click and open the image in a new tab. You can see it's quite large. Coming back to this page, if I turn the width 100% off, and I'm also going to have to turn the height 100% off, you can see the image disappears. And that's just because it's gone huge inside that container. And all we're seeing is the top left of the image here. So it just looks like a white box. So again, setting width 100% ensures that the image nicely fits inside a grid cell. For the next piece of guidance, there are cases when you want to set a button width to 100% so it fills its container and adapts responsively. Let's check in this login page over here. This login form has a container shown in green around the headings, buttons, and inputs. We have buttons at the top over here and the blue button down here. And as you can see, the button stretches the width of the container. And in order to achieve this, we're applying a width of 100%. Again, the parent element here is the container, and we want our button to stretch the full width. So we apply width as 100%. That is 100% of the container width. Let's check this out in the browser. So I'm going to open up DevTools, and I'm going to grab this button element. You can see over here, width is set to 100%. Let's turn that off and see what happens. Now, because a button element is an inline element, we know that it'll just occupy the width of the content. And we can see that with this blue box. So to visually enhance this form, we want to stretch the button the full width of the container. You can see in blue over here. And again, that's done by setting a width as 100%. All right, the last piece of percentage guidance. Percentage values are used for fully rounded corners as pixels require manual calculation. I mentioned in the border radius chapter, we would later be changing our pixel values to percentages. Now we often want fully rounded corners on elements like buttons and images. Let's say we have an anchor tag over here. Its height is 120 pixels, and we set a border radius of 60 pixels. I'm setting it as 60 pixels, as that's half the height. The way this works is we get a radius of 60 pixels inside our circle, and the sections in red are effectively cut away, which leaves us with a pill shape like this. If we had an anchor tag, which was 40 pixels, in order to get fully rounded corners, we would set a border radius of 20 pixels, again half the height. And the same thing happens. We get a radius of 20 pixels, and the bits in red are cut away. So in order to get fully rounded corners, the border radius is half the height of the container. So as you can see for pixels, we manually have to calculate half the height in order to apply a border radius, which gives us fully rounded corners. But using percentages is a lot more effective. Let's say we have the same anchor tag over here, and we now apply a border radius of 50%. We also have the same smaller anchor tag here, and again, we apply a border radius of 50%. So now the border radius is calculated automatically as half of the container. We don't need to manually work out the border radius. And this gives us the same result, fully rounded corners. Alright, we've looked at quite a lot of guidance and had a lot of different percentage values flying around. As promised, I've created a table of common percentage use cases. Just to help summarize this, the first piece of guidance we looked at was for main container. This had a max width property to ensure the content in the container doesn't stretch too wide on larger screens. And we would also apply a width of a value less than 100% to ensure that on smaller devices, the container still had space left and right. We looked at a standalone image. This also had a max width, so the image didn't stretch too wide on larger screens. And we would also apply a width of exactly 100%, so the image scales proportionally as the width of the browser reduces. We looked at images in grids. This just had a width of 100% to ensure that the image filled the grid cell. We also looked at full width buttons, and we saw this used in a form to ensure the button stretched the width of the form. And to achieve that, we applied a width of 100%. And the final case we looked at was rounded corners. And to achieve this, we apply a width of 50%. So let's wrap up this chapter by continuing to add to our CSS unit's summary card. In this chapter, we looked at percentages. The common use cases for percentages was on main containers, images, and border radius. Now you can see border radius is used both in pixels and percentages. We use percentages specifically when we want fully rounded corners, and we use pixels for border radius when they're not fully rounded. So let's go and apply percentages on our Quill homepage. The first place we're going to apply them is on our main container, so that when our page reduces in width, there's space left and right. For us, the parent element is the body tag shown in green, and we have our main container here in red, where we will now go and set a width as a percentage value less than 100% to ensure that as the browser reduces in width, we have that space in white left and right. So let's jump into VS Code and add this to our CSS. So I'm back inside the index.html file, and you can see our main div here with the class container. This div is a child of the body tag. So applying width with a percentage value here will reduce its width in proportion to the body. And the body is just the full width of the page. Let's head over to app.css. I'm going to scroll down to my global styles. And over here we have our container. In a previous chapter, we already set the max width at 1200 pixels. And that's there to ensure that the container doesn't go wider than 1200 pixels on larger screens. I'm now going to go add a width of 90%. And again, this will ensure that when the width of the browser reduces, there's still some space left and right. So let's check this out in the browser. So to see the effect of this, I'm going to go reduce the width of the browser. And as I'm reducing the width, you can see we still have some space left and right. And this is being achieved by having the width set to 90%. I'm going to open up DevTools, and I'm just going to turn the width of 90% off, just to show you what happens. So now again, I'm going to reduce the width of the browser. And as you can see, the content is butting up right against the left edge, which just doesn't look great. So that's what that width 90% is doing. the entire container is 90% the full width of the page. You can see if I go on the body, the current width is 892 pixels. And when I click on the container, its current width is 802 pixels. 802 divided by 892 is 90%. So the remaining space, 892 minus 802, which is 90 pixels, divided by 2, 45 pixels, would be left and right of the main container you see now. And again, just to drive this home, the max width property is there just to ensure that on larger screens, like what I'm on now, the content doesn't extend too far. If I untick this, for larger pieces of content, like this paragraph over here, you can see it just doesn't look great. It's just too wide. Setting a max width on the container ensures all the content is nicely contained within 1200 pixels for larger screen sizes. Now, the second thing we need to do is add a width 100% onto our images. We effectively want to reduce the width of the image so it's less than the max width and stretches to the container edges on smaller screens. I'm back in the app.css file, and I'm going to scroll down to the features section where we have our feature image. The image currently has a max width of 400 pixels, and not so long ago, we actually already added in the width property of 100%. I did this before we knew anything about percentages, but I had to do it back then in order for the image to scale down. But now you'll have an understanding of why we did this. It's because images are inline elements, and if we didn't add the width of 100%, the image's width would remain at 400 pixels, so that when the browser reduces less than 400 pixels, the image would overflow. Applying width 100% to an inline element is essential to ensure that it reduces proportionally as we reduce the width of the browser. So let's check this out. So I'm going to come and inspect the image, and you can see max width of 400 pixels and a width of 100%. Again, the max width is there just to ensure that the image's maximum width is 400 pixels. If I turn that off, the image goes huge. You can see if we look at the box model here, the image is currently 400 pixels. The browser width is 470 pixels. Watch what happens when I reduce the width of the browser. You can see the image is reducing in width. If I turn this property off, you'll see the image scales back to 400 pixels. And again, that's because it's an inline element. And an inline element, when you apply max width, will just be that width, when less than the max width you set. So because we're less than 400 pixels, the image is just set at 400 pixels. In order for it to scale down, we have to explicitly set width as 100%. Now it's time to dive deep into scalable units that help make text and layout more responsive with rems and ems. We'll be discussing what are rems and ems, and we'll be looking at rems and ems design guidance. So what are rems? Rems are a unit that is relative to the root element's font size and are the key ingredient for creating responsive web pages. Now, before we dive in, I just want to highlight rems are really important. They are the primary driving force of making our pages responsive. That is, scaling our content for different screen sizes. So this sentence may not be the clearest, so let's break it down. We'll be talking about the root element first. As a reminder, in our HTML document, we have this HTML tag, which we call the root element. Back in the HTML full course, I spent a chapter on document structure, and you can see over here are these HTML tags. This is the root HTML element which wraps all other elements. It's the same as a book cover wrapping all the pages. In HTML, it's the tags that wrap all the other content. Now the font size of the root element is 16 pixels. And what we're going to see now is that we can size different elements based on the root element's font size of 16 pixels. So let's look at an example of this. I've got over here an anchor tag with different properties. The first property is the font size of the anchor tag, which is currently set to 2 rems. So this font size would be 2 times 16 pixels, which equals 32 pixels. Again, the 16 pixels is coming from the root element's font size, which is 16 pixels. We can also use rems on non-font size properties. So for example, the padding of this anchor tag is currently 0.5 rems, which would be equal to 0.5 times 16 pixels times 8 pixels. Again, the 16 pixels is coming from the HTML root element, which has a default font size of 16 pixels. The last declaration, margin bottom, has a value of 3 rems. This is 3 times 16 pixels, which is 48 pixels. Alright, so you're probably thinking right now, this is just really confusing. What is all this extra work of using this rem value, which is dependent on the root element's font size, and then I've got to multiply numbers by it? Why can't I just put my values like 32 pixels, 8 pixels, and 48 pixels? And I agree with you, it does seem really confusing. But let's go play around in VS Code to get a taste of why rems is so powerful. Alright, I've gone ahead and created this index.html file. I've got an h1, a paragraph, and an anchor tag. I've also linked a style sheet, which is currently empty. So let's head over to app.css and add some rem values to our different properties. I'm going to select the h1. Let's apply a font size of 3 rems, which again is 3 times 16 pixels, which would be 48 pixels. Let's apply a margin bottom of 2 rems, which is 2 times 16 pixels, or 32 pixels. Let's grab our paragraph. We'll give it a font size of 1.5 rems, so 1.5 times 16 pixels, which would be 24 pixels. We'll give it a margin bottom of 1 rem, so 16 pixels. I will grab the anchor tag. We'll give it a padding of 2 rems, which is 32 pixels. Let's give it a background color of light blue. And just so that the padding applies correctly, we're going to change the display property to inline block. And just as a quick reminder, that's because an anchor tag is an inline element, and for box model properties like padding to apply properly, we need to change it to inline block. Alright, so let's check this out in the browser. So you can see the different elements over here. Let's open up DevTools, and let's inspect the heading. You can see it has a font size of 3 rems and a margin bottom of 2 rems. Looking at the box model down here, you can see the margin bottom is 32 pixels, 2 times 16 pixels. If I head over to Computed, you can see the font size is 48 pixels, which is 3 times 16 pixels. And again, just to really drive the point home, all of these values are being calculated off the root element's font size. The default font size of the root element over here is 16 pixels. Now 16 pixels is not the nicest value to work with, so we can actually change this value. Just to show you this, if I make some space here, select the root HTML element and give it a font size of 16 pixels, I'll refresh and you'll see nothing happens. And that's because the default font size of the root element is 16 pixels. Now, as I mentioned earlier, I do want to give a bit of a taste of why rems is so powerful, because at the moment, it just seems like a lot of work. In a later topic, we're going to be learning about media queries. And what media queries allow you to do is apply styling for specific widths of your page, which can be used for specific screen sizes, like mobile, tablets, and desktops. So for different screen sizes, what we're going to do is actually change the font size of the HTML root element. So for example, on a mobile, we might want our root element's font size to actually be 8 pixels. If I refresh the page, our font size, margin, and padding all dynamically updates by changing a single value. That is, the font size of the root HTML element. And for larger screens, we might set it to a value like 20 pixels. I'll refresh, and you'll see all the values dynamically update, all based off the root font size. Alright, I'm just going to go change this back to the default font size of 16 pixels. Now the default root element font size of 16 pixels is not the nicest value to work with. But let's go and see how we can make our lives a bit easier. Working with a base 10 pixels for rem units makes it simpler when thinking about sizing elements. My advanced maths is pretty good, but my basic maths sucks. So when I'm thinking of values, to have 16 as my base unit to multiply with fries my brain a bit. But 10 pixels is much easier to work with. So what we can do is inside our CSS file, we can select the HTML root element. So it's fixed at 10 pixels, which means 1 rem now equals 10 pixels. So let's go add this in VS Code. So I'm back inside our app.css file, and I'm just going to go update the root HTML font size to 10 pixels. I'll refresh, and you can see straight away all these elements adjust. Now the font size is 3 times 10, which is 30 pixels. Just so that we can use this new value, let's go change the font size to be 5 rems, which would be 5 times 10 or 50 pixels. Let's go open up DevTools just to confirm this is the case. I'll select the heading. You can see a font size of 5 rems. Heading over to Computed, we can see a font size of 50 pixels. I can also confirm on the HTML root element, we can see the font size of 10 pixels And if I go to computed, the font size is 10 pixels. So that's now the base unit we're working with. Now working with 10 pixels is certainly a lot better, but we do need to account for one more thing. What I want to show you is that your browser has a default font size it's using. Inside Chrome, I'm going to click these three dots. I'm going to head over to Settings. I'm going to go to Appearance, and you can see over here font size. This is currently set to medium, which is recommended. Now medium is 16 pixels. Looking at some other values, very small is 9 pixels, small is 12 pixels, large is 18 pixels, and very large is 24 pixels. Now I just leave my screen at medium, but whenever I grab my mum's laptop or phone, the text is seriously massive. It takes about 10 times longer to scroll through a page when looking at something on her phone. So to make it easier for her to read, she's using large or very large as her font size. Now the problem with setting font size at 10 pixels overrides those font sizes in the browser, which means that if someone were to go adjust the font size in their browser, like my mum, it just wouldn't scale accordingly. So to fix this, we instead set a font size of 62.5%. So where does this number come from? Well, we want our font size to be 10 pixels. All I've done is divide 10 by 16, which is 62.5%. 10 pixels is the value we want for a medium screen, but in the browser, the medium screen is set at 16 pixels. So what I'm doing is I'm effectively taking 16 pixels, which is the browser's font size, and multiplying that by 62.5%, which then gives me 10 pixels. And using a percentage value like this means we can use the different font sizes and just apply 62.5% to each of them. So this will scale if the user updates their browser font size. Looking at some mathematical examples, for medium, 62.5% times 16 pixels is 10 pixels, which is the value we want. And for very large screens, 62.5% times 24 pixels is 15 pixels. Again, the 24 pixels comes from the very large font size. So by using 62.5% for the different font sizes in the browser, we're multiplying each of them so that if someone were to go change their browser font size, everything still scales nicely. So let's go and update that inside VS Code. I'm just going to change our 10 pixels to 62.5%. If I refresh, nothing will happen. But now we've ensured that if the font size of the browser changes, this will scale accordingly. And just to demonstrate this inside the browser, let's go to the settings. I'll go to Appearance. For the font size, let's change it to very large. You can see the text goes very large. It's taking the browser's very large font size, which is 24 pixels, and multiplying it by 62.5%. Let's go change it to very small, and you'll see everything goes much smaller. The very small font size value is 9 pixels, so it's taking 9 pixels and multiplying it by 62.5%. All right, I'm just going to change it back to medium, and I want to show you what happens if we left this at 10 pixels. As you can see, there's been no change because 10 pixels is the same as 62.5% times 16 pixels, which is the medium case. But watch what happens now. If I go change this to very large, there's no change. And if I change it to very small, there's also no change. And that's because doing this is overriding the font sizes you set in your browser. So that's why using a percentage value is a lot better. Let's now take a look at some REMS guidance. REMS are commonly used on font size, margins, and paddings to create fully responsive web pages. I have this homepage on the left over here. We have some padding applied above the main heading, and you can see the font size is quite large. Looking now at the mobile version of this page, the padding over here reduces, and the font size also reduces. And as I've mentioned, when we learn about media queries later on in the course, all we're going to be doing is changing the font size of the root HTML element for different screen sizes, which will automatically adjust the font size, margin, and paddings for different screens. Let's now look at EMs. Now, EMs are not as frequently used as REMs, but we do need to go through them, as you will see them out there in the wild, and you also may want to use them in your own project. EMs is a relative unit that is more context-specific compared to REMs. When I say context-specific, I just mean closer. As you know by now, inside an HTML file, you can have many levels of nesting. REMs are relying on the root HTML element, which could be many nested layers above the element you're styling. Ems are not based on the root element. They're based on an element much closer to the specific element that you're now styling. Now, there are two main use cases of Ems. The first is for typography, where the element you are styling is relative to the font size of the parent. Properties you would use include font size, line height, and letter spacing. And again, I really want to highlight that we're relative to a parent now, and not the root HTML element. Our reference point is much closer or context specific. So let's go play around with this inside VS Code. All right, so I've gone ahead and set up a new index.html file. I've created a div, which has a class feature1. I have an h1, which has a class feature heading. I have a paragraph, which has a class feature paragraph. And I have an anchor tag with the class feature button. So let's move across to app.css. I'm going to select feature1, which again is our parent element. And I'm going to set its font size as 10 pixels. I'm going to select the feature heading, and I'm going to give it a font size of 2ems, which is 2 times the 10 pixels. As we discussed earlier, ems is based on a parent element's font size. Because I'm setting this parent's element font size to 10 pixels, the font size of the heading will be 2 times 10, or 20 pixels. Let's go set some other properties nested inside the div. We'll select the feature paragraph. Let's give it a font size of 1em, so 1 times 10, which is 10 pixels. And let's select the feature button, which is that anchor tag. We'll give it a font size of 0.5ems, 0.5 times 10, which is 5 pixels. Let's also just give it a background color of light blue. All right, let's check this out in the browser. So you can see our heading, paragraph, and anchor tag over here. Let's just go confirm their sizes. I'll open up DevTools. I'll select the heading. You can see its font size is 2ems. And if I go to computed, you'll see the font size is 20 pixels. That's 2 times 10 pixels we set on our parent element. Now, if I go change the font size of the parent element, so let's go make it 20 pixels, you'll see all the values will double. So now the font size is 40 pixels of the heading. Now, just to really highlight that ems are based on a parent as opposed to the root element, let's go back into index.html. I'm going to copy this and paste it here. And I'm going to update this class to feature2. Inside app.css, I'm just going to change this back to 10 pixels. And I'm going to go select feature2 and give it a font size of 20 pixels. And these styles are still being applied to the content inside both feature1 and feature2. So let's check this out in the browser. So what we can see here, because the feature1's container has a font size of 10 pixels, whereas our feature2 container has a font size of 20 pixels, the elements in here are effectively double the elements in here. Because feature1's font size is 10 pixels, whereas feature2's font size is 20 pixels. Now, you just wouldn't be able to do this with rems. Just to demonstrate this, I'm going to remove these styles. I'm going to get our HTML root element. I'm going to set its font size to 10 pixels. And I'm just going to update these all to rems. If I refresh, you'll see both feature1 and feature2 are now the exact same. And that's because they're all being based off the single HTML root element. Whereas before, I was able to size the features differently based on the parent element's font size. Now, in addition to typography, we can apply ems to other properties. And these are relative to the font size of the element itself. Common properties include width, height, margin, and padding. That is, box model properties. Let's play around with these in VS Code. I'm back inside the index.html file we were just in earlier. I'm going to go remove all of this. I'm just going to add a single anchor tag. For now, I'll point it to Google. I'll just have the text, click me. Inside app.css, I'm going to remove all these styles. I'll select the anchor tag. Let's give it a font size of 50 pixels, padding of 20 pixels, top and bottom, 40 pixels left and right. Let's give it a border radius of 20 pixels. Let's give it a background color of light coral. And for the box model properties to display properly, we need to change this display property to inline block. All right, let's check this out in the browser. So as expected, we have a button component. Now, this is obviously quite a large button. If I had a smaller button in the application and I wanted the font size to be 10 pixels, if I only change the font size and refresh this, you'll see this just looks quite bad. There's way too much spacing around the element. So instead, I can do this. So let me first just change this back to 50 pixels. So a better approach would be allowing us to scale the button based on the font size. So to do this, we can use the font size of the anchor tag set here and apply M properties to the padding and border radius. And that way, when we change the font size, these two properties